Beneath the surface of the ocean lies a world more vast and alien than anything we found in the stars. A place where sunlight dies, pressure crushes steel, and time itself seems to move differently. It is a realm of silence and shadows, of strange lights flickering in the dark, of whispers in the current that no one can trace, of colossal forms that vanish before we can name them. We've mapped the surface of Mars in more detail than we've explored our own seabeds, and in that crushing blackness, there are things we cannot explain. Structures that resemble ancient ruins, sounds that echo across the abyss with no visible source, creatures that defy biology as we know it, entire ecosystems that thrive without sunlight, heat, or oxygen. The deeper we look, the more we realize we know almost nothing. What secrets are buried in the trenches? What forces shape the ocean floor when no one is watching? What else might be down there waiting? So sit back, relax, and let's dive into the unknown. These are the deep-sea mysteries science can't explain. In the cold, silent waters between Sweden and Finland, where the Baltic Sea stretches like a sheet of liquid steel, there lies something strange, something that has captured the imagination of scientists, divers, and conspiracy theorists alike. Nearly 300 ft below the surface, resting on the ocean floor, is a formation that should not be there. A massive circular object nearly 70 meters wide, shaped eerily like a disc with features that seem too geometric, too intentional to be a natural formation. Discovered in June 2011 by a team of Swedish treasure hunters from the OceanX diving group, the object immediately sparked controversy. The sonar image showed a shape that seemed more at home in science fiction than marine geology. Smooth, rounded edges, a central dome, a tail-like structure stretching out behind it. The initial readings suggested a sort of staircase or ramp leading up to its side, and below it, a disturbance in the seabed, as if the object had slid into place or landed with force. At first, the discovery was framed as a curious geological find. The OceanX team was searching for sunken ships, hoping to locate a cache of old champagne or liquor from World War I. What they found instead was a mystery that has remained unresolved for over a decade. Skeptics, geologists, and marine scientists have since examined the data. Some say the object is nothing more than a glacial deposit, a remnant from the last ice age when sheets of ice thousands of meters thick carved the land and deposited massive rocks in unusual formations. Others suggest it's a natural basalt outcropping shaped by millions of years of underwater erosion. But even among experts, the formation's near-perfect symmetry, sharp edges, and odd features don't fit comfortably within any known category. Adding to the intrigue are the strange phenomena reported by the OceanX crew during their dives. Their electronic equipment reportedly malfunctioned when approaching the anomaly. Lights cut out. Cameras refused to operate. Satellite phones went dead. When they moved away, everything returned to normal. Coincidence, environmental interference, or something else? Some divers also noted an unusual texture to the surface, describing it as unlike any rock they had encountered before. In some places, it was rough and scorched, as though subjected to intense heat. And in one corner of the formation, they discovered what appeared to be a perfectly circular hole leading into darkness. The deeper the investigation went, the more questions arose. If this object was natural, why had nothing like it been found elsewhere in the Baltic? Why did it resemble, in the sonar image, at least a classic flying saucer, complete with a domed top and a stair-like structure on one side? Was it a geological curiosity or something more? Inevitably, theories began to emerge. Some suggested it could be the remains of a sunken World War II-era anti-submarine device. Others believed it was a lost piece of a submerged city or ancient civilization, perhaps dating back to a time before the last glacial melt swallowed parts of northern Europe. The more speculative corners of the internet proposed it was an alien craft resting quietly on the seabed after some unknown crash landing. One popular fringe theory points to the object's uncanny resemblance to the Millennium Falcon from Star Wars, while The similarity could easily be chalked up to coincidence and the human tendency to find patterns. It has nonetheless fueled popular interest in the anomaly. Could our collective memory or imagination be rooted in something older, deeper, and somehow real? Adding fuel to the mystery, the Ocean X team released further footage and statements in the years following the discovery. One diver claimed that parts of the object felt like metal rather than stone. Another stated they had found what looked like corridors or passageways inside the formation, though no definitive evidence of such structures was ever released. The team also reported samples of a black stone from the object that scientists could not identify as common to the area. Despite these claims, no large-scale scientific expedition has returned to study the anomaly in detail, perhaps due to lack of funding. Perhaps because the Baltic's murky waters and treacherous currents make diving conditions exceptionally difficult. Or perhaps, as some believe, because those in the know don't want the answers found. But is there anything there that science truly cannot explain? Or are we simply seeing what we want to see, interpreting ambiguous shapes and sonar readings through the lens of our deepest fascinations? What we know is this: the Baltic Sea anomaly is real. It is there, resting in silence at the bottom of one of the world's most mysterious bodies of water. Whether it is a glacial relic, an ancient ruin, or something far stranger, it remains unclassified, unsolved, undisturbed, and maybe that's what makes it so haunting. Could this be one of Earth's forgotten chapters buried beneath sediment and time, or just another example of nature defying our expectations? For now, the object remains in the dark, quiet, waiting, and the question lingers. What else lies hidden in the depths of our own planet, just beyond the reach of light? Just beyond the cold, brackish waters of the Baltic, where an unexplained structure lies still beneath the sea, another enigma waits. Half a world away, beneath the warm blue waves of the Pacific Ocean, a land of shifting tectonic plates, deep trenches, and ancient myths. Here off the southern coast of Japan's Ryukyu Islands lies Yonaguni, a rugged, wind-swept island where ocean currents are fierce and the sea floor drops steeply into the abyss. But it's not what sits above the waves that draws the curious. It's what was found below them. In 1986, a local diver exploring the waters near Yonauni's southern coast made a startling discovery. Beneath, nearly 30 feet of clear seawater carved into the bedrock of the ocean floor was a structure unlike anything else in the region. Massive angular formations, terrace steps, perfectly flat surfaces and geometric edges that looked almost architectural. And standing out most of all, a wide flat platform shaped like a ziggurat or stepped pyramid rising from the seabed in layers like an ancient altar. From above, it looks unmistakably like a man-made monument. Divers and researchers have since dubbed it the Yonauni Monument, a name that carries the weight of mystery and the echo of civilizations long lost. Measuring over 150 meters in length and 40 meters in width, the formation appears too precise, too deliberate to be accidental. Right angles, smooth planes, and a sense of proportion and symmetry that seems to follow some hidden blueprint. But is it a relic of a forgotten civilization or merely a trick of nature? Geologists have weighed in. Some argue that the structure is the result of natural tectonic activity and erosion. The region lies along the Pacific Ring of Fire, one of the most seismically active zones on Earth. Earthquakes, tsunamis, and undersea landslides have shaped this coastline for thousands of years. According to this view, the rock formation is simply a product of sandstone fracturing along regular fault lines broken down over time by water and waves. Yet there are details that resist easy classification. Beneath the monument's central platform lie what appear to be wide, stair-like steps, each almost perfectly aligned. To the side, a large trench, sharp-edged and almost too straight. And within the formation itself, divers have reported features that resemble corridors, gateways, and even what some have interpreted as symbolic carvings. A few researchers have gone further, Professor Masaki Kimura, a marine geologist from the University of the Ryukusei, has spent years diving and studying the site. He believes the formation is at least in part man-made and may be the ruins of a sunken city, possibly dating back more than 10,000 years to a time when sea levels were significantly lower. If this is true, it would challenge the conventional timeline of human civilization. Could Yonaguni be a remnant of an unknown culture that thrived before the end of the last ice age? A culture lost to rising seas and seismic catastrophe. Some even link the structure to the fabled lost continent of Mu, a hypothetical Pacific civilization that supposedly vanished beneath the ocean thousands of years ago. Though mainstream historians largely dismiss the MW theory as myth, the visual impact of the Yonaguni monument is hard to ignore. It taps into something deeper, a quiet suggestion that not all of human history is accounted for. But even if we leave aside speculation, questions remain. Why does the formation resemble a step pyramid? An architectural form echoed in ancient structures across the globe, from Egypt to Central America to Mesopotamia. Could that shape arise independently, in stone without the guidance of human hands? And what about the alleged carvings? Kimura and others claim to have identified pictographs or inscriptions on the rocks, weathered but deliberate. Critics argue these marks are the result of natural abrasions, cracks, or wishful thinking. But like many such mysteries, interpretation rests in the eye of the beholder. Adding to the enigma is the challenge of dating the structure. The formation is carved directly into the bedrock, leaving no organic material to carbon date. If the monument was shaped by human tools, they left no trace, no pottery shards, no tools, no bones. Only the stone remains. There's also the matter of the sea itself. Over millennia, coastlines change. Sea levels rise and fall. What is underwater today may once have stood on dry land. Around 10,000 years ago, much of the Earth's water was locked in glacial ice. As the climate warmed and the glaciers melted, ocean levels rose dramatically, flooding coastal settlements and erasing entire landscapes. Could Yonaguni have once been part of such a coastline? Its structures shaped by ancient hands, later consumed by the sea? And if it was a city, a temple, or a fortress, who built it? And why has no trace of them been found elsewhere? For now, the monument sits in quiet defiance of certainty. Bathed in shifting light, visited only by divers and darting fish, it endures as one of the great puzzles of the underwater world. Its stone faces seem to whisper in the current, holding on to secrets carved deep in time. Is it nature mimicking design, or design mistaken for nature? As we move forward, the monument reminds us of how much we have yet to discover. Not in distant galaxies, but right here on our own planet. Because sometimes the greatest mysteries are the ones lying just beneath the surface. Just as the stone-carved enigma of Yonaguni fades beneath the currents of the Pacific, another mystery emerges. Not from the depths, but from the surface itself. A mystery that stretches for hundreds of kilometers, illuminating the sea in a soft, ghostly glow. It's not a monument, or a shipwreck, or a forgotten city. It is the ocean itself shining in the darkness. This is the Milky Sea effect, a rare and haunting phenomenon where vast stretches of the ocean begin to glow with an eerie, pale blue light. Not for seconds, not for minutes, but for hours. Sometimes even through the night, and not in patches, but across entire regions of the sea, larger than some countries. Imagine sailing in the Indian Ocean, far from any coastline, under a cloudless sky. The moon hasn't risen. The sea should be black, featureless, infinite, but instead it glows softly, uniform, steady, as if lit from below. There is no sound, no waves, no apparent cause, just light, not reflected but emitted, like drifting through a sea of stars. The phenomenon has been reported for centuries. One of the earliest written accounts comes from 1849, when the crew of the British vessel SS Lima described sailing through a field of glowing water stretching as far as the eye could see. They said the light was so bright they could read by it that the ocean had turned into a luminous field with no visible boundary. Since then, similar reports have emerged sporadically, mostly from the Arabian Sea. The waters south of Java and other remote parts of the Indian Ocean. Always at night, always unexpected and always unexplained. But is it real? In 2005, scientists confirmed its existence for the first time using satellite imagery. A massive patch of glowing water over 15,000 kilometers, roughly the size of Connecticut, was detected off the coast of Somalia. The glow lasted for several consecutive nights. The data matched a ship's log from a nearby vessel whose crew reported sailing through strange glowing waters at the exact same time. The satellite data was real. The ship's account matched. The Milky Sea effect wasn't folklore. It was happening. So what causes it? The leading theory points to bioluminescent bacteria, specifically a type known as Vibrio Have. Unlike the more familiar flashes of blue caused by dinoflagellates, those glowing waves seen along beaches in warm coastal waters, Vibriobacteria emit a steady cold light, and under the right conditions, they can multiply rapidly, creating vast colonies that drift across the sea. It's believed that the bacteria form symbiotic relationships with algae or other microscopic organisms, gathering in massive blooms under specific environmental conditions: low wind, calm currents, stable temperatures, and nutrient-rich waters. Once their population reaches a critical mass, they may begin to emit light as a kind of group signal, a form of quorum sensing. But here's where the mystery deepens. No one has ever sampled a Milky Sea event directly. No ship has collected a vial of the glowing water while it was happening. No research expedition has been able to catch it in real time. Despite the satellite confirmations, the phenomenon remains frustratingly elusive. Why does it occur only in certain regions? Why is it so rare and yet when it does happen so massive? How do these bacteria coordinate across distances of dozens or even hundreds of kilometers? And why produce light at all? Some researchers have speculated that the glow may serve a defensive function, distracting predators or confusing fish. Others think it may play a role in microbial communication, like a luminous broadcast stretching across the sea. Still, no one knows for certain. Then there are the accounts that don't quite fit the bacterial model. Some sailors describe the glow as having no visible source, no particles, no movement, just a smooth, featureless shine. Others have said the glow seems to dim and brighten as ships pass through it, or that it pulses gently like a living thing. A few even claim that the water feels different, as though something has changed in its texture or weight. These reports are anecdotal, unverified, but they raise questions that science hasn't yet answered. Could there be another cause, something we haven't yet identified? A few fringe theories suggest that Milky Seas may be linked to undersea geothermal activity or even electromagnetic forces generated by the seafloor. Others whisper about unknown marine organisms larger, more complex than bacteria lurking in the deep, releasing light in some ancient, unseen rhythm. Some even point to natural phenomena we barely understand. Rogue currents, deep ocean gases, or unexplored interactions between biology and chemistry in the vast, unlit reaches of the sea. But perhaps the most unsettling question is this: how many times has it happened without anyone seeing it? In the age before satellites, before radar and global tracking, the sea was a wilderness. And the Milky Sea, with all its subtlety, could have bloomed and vanished 1,000 times over, known only to the waves and the wind. Even now, with all our technology, we still rely on chance, on a ship happening to pass through the right patch of ocean at the right time, with someone on board willing to look and remember. The rest is silence. The Milky Sea effect remains one of the ocean's most gentle yet haunting mysteries. Not threatening, not terrifying, just quietly unknowable. A reminder that not all secrets announce themselves with noise or drama. Some glow faintly in the dark, asking nothing more than to be seen. What ancient rhythms shape this phenomenon? What else waits on the open sea just beneath the veil of night? We move onward. The ocean has more to reveal. As the glowing expanses of the Milky Sea fade behind us, we begin to descend deeper than the reach of light, farther than the grasp of most machines, into one of the most extreme and least understood places on Earth, a place so deep, so pressure-crushed and remote that only a handful of people have ever laid eyes on it. This is the Challenger Deep, the deepest known point of the world's oceans. It lies buried within the Mariana Trench, a massive undersea canyon that arcs across the western Pacific. Ocean like a scar just east of the Marana. Islands and south of Japan, stretching over 1,500 mi in length and plunging nearly 7 mi straight down. The trench is a geological wound formed where the massive Pacific plate is being forced beneath the smaller Marana plate, a process known as subduction. The bottom of this trench is not just deep, it is otherworldly. At its lowest point, measured at roughly 10,984 meters, or about 36,37 ft, the pressure is more than 1,000 times greater than at sea level. Down here, every square inch is subject to over 8 tons of crushing force. It's an environment where metal bends, electronics fail, and the human body would be flattened instantly. No sunlight ever reaches this place. It is a world of eternal blackness, bitter cold and silence so complete it borders on the surreal. And yet there is life. From the moment scientists first began probing these depths, the assumption was that such an environment would be lifeless, too dark, too cold, too hostile. But every time we go deeper, we are proven wrong. In 1960, Swiss oceanographer Jacques Picard and US Navy Lieutenant Don Walsh made the first manned descent to the Challenger Deep in a steel-hull submersible called Trieste. What they found at the bottom surprised them. A flat, silt-covered plain and movement. A small fish-like creature. Life surviving where life was not expected. Since then, remotely operated vehicles and more recent manned missions such as James Cameron's solo descent in 2012 have revealed an astonishing variety of life forms. Amphipods, giant single-celled xenophores, holtherans, and microbial colonies that thrive on chemicals rather than sunlight. Creatures that are pale, translucent, slow-moving, evolved for pressure, not speed. Organisms whose biochemistry still puzzles us. And yet, as remarkable as these discoveries are, they barely scratch the surface. Less than 5% of the Mariana Trench has been thoroughly explored. Most of it remains untouched, unseen, and silent. What else might be down there? This question, whispered among oceanographers and dreamers alike, has given rise to speculation. Not because we lack facts, but because the facts themselves leave so much space for wonder. Some researchers have suggested that there could be entire ecosystems hidden within deep trenches sealed off from the rest of the world for millions of years. Self-contained pockets of biological evolution shaped by pressures and chemistries unlike anywhere else on Earth. Others wonder about the possibility of unusual forms of life radically different from what we know. Could organisms exist that do not rely on DNA as we understand it? Could extremophiles species live in a way that defies our current definitions of biology? Even the geology of the trench poses questions. The immense pressure causes chemical reactions that can create strange minerals, metallic compounds, and structures that remain largely unstudied. Some theories suggest there may be superheated liquid pockets, or even natural nuclear reactors deep within the Earth's crust beneath the trench. Phenomena that could influence the chemistry and even the physics of this unique environment. And then there are the stranger whispers, fringe theories offered not as answers, but as provocations. There are those who speculate that the Challenger Deep, shielded by pressure and depth, could hide ancient relics, fragments of long-lost civilizations swept away by time and tectonic shifts. Some have pointed to sonar anomalies and unexplained symmetrical patterns in barometric scans, suggesting the possibility, however remote, of man-made structures buried in the abyssal plain. Others go further still, myths of deep-sea leviathans. Reports long dismissed of enormous unidentified shapes picked up on sonar. A handful of declassified naval documents describe strange underwater sounds, low sustained roars or pulses originating from depths well beyond the range of known marine life. Could something unknown inhabit the deep? Something that has never breached the surface? Most of these ideas remain unproven and many are likely misinterpretations. But in a place where 97% remains unexplored, how confident can we really be in dismissing the improbable? The Challenger Deep is not just the bottom of the ocean. It is the bottom of our understanding, a place so isolated, so extreme, that it might as well be another planet. In fact, it has been said that we know more about the surface of Mars than we do about the floor of the Mariana Trench. And that is what makes it so haunting. Not what we found there, but what we haven't. Not the alien fish or ancient rock, but the vast stretches of silence between them. The absence of evidence in a place so large, it almost guarantees the presence of something we've yet to see. What forms of life might still lurk there, hidden from the sun for eternity? What secrets lie buried beneath that crushing darkness, untouched by time or tide? And perhaps most of all, what else have we yet to discover in the last truly unreachable corner of our own planet? We move forward slowly into the dark. The trench waits. As we leave behind the crushing depths of the Mariana Trench, where the ocean folds into itself and light ceases to matter, we ascend slightly but not to safety. Instead, we arrive at another alien landscape no less haunting, a place where lakes form inside the sea, where water sits atop water, where life meets a boundary and often does not survive it. These are the underwater brine pools, also known as hypersaline lakes, or more simply, lakes within the ocean. Hidden in the deep reaches of the Gulf of Mexico, the Red Sea, and other abyssal zones around the world, these pools seem at first glance like optical illusions. From the view of a submersible camera, you can see waves lapping at a shoreline. You can see ripples, currents, even what appears to be a beach, but the entire scene lies thousands of meters beneath the ocean surface. It's not an illusion. These are real lakes formed from ancient salt deposits, dissolving into seawater over thousands of years, creating concentrated basins of brine. Salt water so dense it resists mixing with the water around it. The salinity can be up to 8 times higher than that of normal seawater. The density difference is stark enough that it creates a physical boundary, a second surface beneath the sea. To peer into one of these pools is to gaze into a mirror of the impossible, a self-contained body, motionless and smooth, encircled by cliffs, shores, and often ringed by strange, glistening deposits of white salt. Around the edges, the seabed sometimes appears scorched as if burned, and the life forms nearby, they are different, adapted, twisted, alien. Brine pools are lethal to most marine life. For fish or invertebrates that wander too close, the boundary acts like a trap. Once inside, the lack of oxygen and the chemical toxicity of the brine, often rich in methane, hydrogen sulfide, and heavy metals, can kill within minutes. Crabs, shrimp, and other deep-sea creatures have been found preserved along the edges as though flesh frozen in place. Their bodies lie still, never decomposing in the near-sterile brine. And yet life persists within and around some brine pools. Scientists have discovered thriving microbial ecosystems, bacteria and archaea that survive without sunlight, without oxygen, without anything resembling a normal environment. These extremiles feed on chemical reactions like methanogenesis or chemosynthesis, drawing energy from sulfur, methane, and metal-rich minerals. In some places, these microscopic communities form thick mats, almost like carpets on the edges of the pools, glowing faintly under certain light, undulating with the current, hinting at the presence of something both ancient and persistent. In others, researchers have observed unique tube worms, clams, and symbiotic organisms that live entirely cut off from the surface world. dependent on invisible chemical exchanges. Could these ecosystems resemble what life looked like on Earth billions of years ago, before oxygen, before photosynthesis? Or might they hint at what life could look like elsewhere on the moons of Jupiter or Saturn, beneath ice-covered oceans in distant solar systems? The implications are vast, and yet, even here, in the realm of science and observable phenomena, questions linger. Some brine pools appear to form in ways not fully understood, gathering in patterns that seem too organized, too geometric. In certain cases, researchers have observed circular depressions with symmetrical boundaries, as if shaped by intention rather than erosion. Could these forms be coincidental, or is there a deeper structure beneath them that we have yet to uncover? In 2016, a brine pool in the Gulf of Mexico, nicknamed the Jacuzzi of Despair, drew international attention. Lying nearly 3,300 ft below the surface, the pool was found to be so toxic that anything entering it died almost instantly. But what fascinated scientists even more was the fact that it appeared to pulse, as if breathing, as if alive. Fringe theorists have latched onto these pools as potential entrances to deeper hidden chambers beneath the seabed. Cavities of superheated water or networks of ancient geothermal tunnels. A few even suggest that brine pools might function as natural containment zones, places where gases or biological materials are sealed off from the rest of the ocean. Not by design, but by geological coincidence, or perhaps not coincidence at all. Some have drawn comparisons to Siberia's doorways, deep, strange sinkholes that appear overnight. Could these undersea formations be similarly transitional? Are we only seeing the surface of something much larger, much more complex? So far, few of these questions have clear answers. Brine pools are difficult to reach and even harder to study. Their extreme chemistry erodes equipment. The pressure and depth make sustained observation costly and rare. Most of what we know comes from brief glimpses, robotic dives, scattered data points, grainy footage. But one thing is certain: wherever they are found, they are isolated, deadly, and utterly unique. They do not move with the tides. They do not mix with the ocean. They remain apart like hidden rooms within the sea, sealed off, self-contained, and filled with substances and forms of life that seem to belong to another planet. What else lies beneath their surface? What might we find if we could dive deeper into their depths, into the sediments below, into the layers of ancient water sealed off for millennia? Are these pools simply byproducts of geology? Or are they thresholds, natural boundaries between the known and the unknown? We don't know yet. From the still deadly quiet of the underwater brine pools, we continue our descent through the Earth's deepest and least explored realms into places where the seafloor itself is alive, shifting, cracking, and erupting in silence. Hidden far beneath the waves, often thousands of meters down, lie some of the planet's most powerful and mysterious geological structures. Undersea volcanoes, they rise from the abyssal plain like ancient towers, sometimes taller than mountains on land, yet cloaked in eternal darkness. These are the unseen engines of the Earth, massive structures that shape continents, Earth islands, and sometimes vanish without warning. Unlike their fiery cousins on land, submarine volcanoes often erupt unnoticed. There is no smoke, no lava spilling down slopes, just a surge of heat, a pulse of chemicals, and the quiet movement of stone reshaping the ocean floor. Over 3/4 of all volcanic activity on Earth occurs underwater, along massive fault lines such as the Mid-Atlantic Ridge or the Pacific Ring of Fire. And yet, only a fraction of these volcanoes have been observed directly. The rest remain hidden beneath miles of water and sediment, unmapped, unnamed, and unknown. But sometimes they make themselves known. In 2012, a massive volcanic event occurred off the coast of New Zealand. Deep beneath the surface, a previously unidentified volcano erupted with such force that it released a pumice raft the size of Belgium, a floating mass of volcanic rock that drifted across the Pacific for weeks. Satellites captured its pale surface, reflecting sunlight, a ghostly, drifting continent that had appeared overnight. But the volcano responsible for days, no one knew its name or even where it had been. Only through seafloor mapping and careful analysis was the culprit identified. Havre Seamount, an undersea volcano never previously observed, now known to have unleashed one of the largest deep ocean eruptions in recorded history. How many such eruptions have gone unnoticed? How many other havres lie waiting beneath the waves? Some undersea volcanoes are well studied, like those in the Lau Basin or along the East Pacific Rise. Here, remotely operated vehicles have captured footage of molten lava spilling across the ocean floor, instantly cooled into bizarre pillow-like shapes. Jets of superheated water shoot from the seabed, creating shimmering towers called black smokers, and surrounding them, entire ecosystems bloom, life born not of sunlight, but of the Earth's raw chemical fire. But not all volcanoes fit this pattern. In certain locations, especially along remote tectonic boundaries, researchers have identified volcanic structures that seem oddly symmetrical, almost artificial in shape, perfect cones, smooth ridgelines, crater-like depressions that some have compared, however cautiously, to massive impact sites. At the same time, sonar scans have occasionally revealed anomalies, formations resembling domes or geometric mounds that defy easy classification. Could these be collapsed calderas, hydrothermal features, or something else entirely? The pyramidal seamount south of the Azores, for instance, has drawn curiosity for its sharp edges and steep triangular sides. Mainstream geologists explain it as the result of lava flow solidifying along ancient fault lines, but to others it looks strangely out of place, almost sculpted. And then there's the issue of unexplained sounds. In 1997, the National Oceanic and Atmospheric Administration recorded a mysterious ultra-low frequency sound in the South Pacific, dubbed the bloop. It was one of the loudest underwater sounds ever recorded, and some scientists initially speculated it could have been caused by a massive undersea volcanic eruption. But the sound bore characteristics unlike any volcanic tremor. It was organic in nature, some said, almost animal-like. Later explanations attributed it to ice quakes, large icebergs fracturing, but not everyone was convinced. Could an undersea volcano or something living within one have produced it? Fringe theorists have gone even further. Some suggest that certain undersea volcanoes might be more than just geological, that they could be gateways, vents, not just for heat and magma, but for something older and hidden. Stories persist, particularly in Pacific Island cultures, of places where the sea boils and gods rise from the deep. In these tales, volcanoes are not just features of the landscape, they are the breathing points of the Earth itself. While science approaches such ideas with skepticism, even researchers acknowledge how little is known about the deep ocean volcanic system. Most underwater eruptions are inferred only after the fact through water temperature changes, chemical traces, or subtle shifts in seismic activity. Very few are seen, even fewer are studied in detail, and yet they keep reshaping the world. They build islands, they collapse coastlines, they alter ocean currents and trigger plumes that can impact climate itself. In the vast darkness of the ocean, these volcanoes are not dormant. They are active, ever-changing, and mostly invisible, so what else lies hidden beneath their slopes? Could some of these massive undersea mountains house caverns or voids beneath the crust? Could unknown forms of life be feeding on the heat and minerals erupting from their cores? And when a volcano that no one has ever seen suddenly erupts, changes the landscape, and then falls silent again, what else might it have disturbed? The ocean floor is more alien than the surface of the moon, and undersea volcanoes may be its most powerful, unpredictable, and mysterious features. We don't yet understand them, not fully, and until we do, each shadow on the seafloor, each silent plume in the current, is a question left unanswered. A breath held in the dark, waiting to be found. From the towering forms of underwater volcanoes, those silent giants rising from the ocean floor, we turn our attention to something far more subtle, yet equally haunting. Not flame or stone or heat, but sound. A strange, resonant vibration that echoes through the water in long, drawn-out tones. Tones that seem almost melodic, almost alive. These are the singing sand dunes of the ocean, an elusive phenomenon heard, but rarely seen. Murmurs from the seabed that baffle scientists, intrigue explorers, and whisper a riddle through the currents. Deep beneath the waves, particularly along continental slopes and sandy seabeds, divers and submersibles have occasionally reported a low, continuous humming, an otherworldly tone that seems to rise from the ocean floor itself. In some cases, it has been described as a deep, almost musical moan. In others, a pulsing vibration felt more than heard. This isn't the roar of underwater earthquakes or the familiar clicks and calls of marine life. It's something different, tuning itself to no obvious rhythm, following no seismic event, simply singing. The most well-documented terrestrial analog comes from the deserts, certain sand dunes in remote parts of the world. Morocco, Chile, China are known to emit a deep, resonant hum when disturbed by wind or movement. The effect, called booming sand or singing dunes, is caused by the synchronized movement of sand grains which vibrate together to produce a haunting harmonic frequency. Some of these tones can last for minutes. They sound like a pipe organ echoing across empty valleys. Could the seafloor exhibit something similar? Recent research suggests it's possible. In places where underwater dunes form, massive shifting ridges of sand sculpted by powerful currents. The grains may be fine enough and dry enough within air pockets or sediment-laden cavities to create friction and resonance. When triggered by underwater landslides, gas releases or sudden sediment shifts, these dunes might sing as their terrestrial cousins do. The vibrations could be carried through the water, giving rise to the long, strange tones occasionally picked up by hydrophones or felt by divers, but the data is fragmentary and the phenomenon is rare. One of the most curious cases was documented off the coast of Oman near a submarine desert known for its sweeping underwater dunes. In 2014, a research team recorded a sustained low-frequency hum lasting nearly 2 hours. It was too uniform for tectonic activity, too deep for whale song, and too consistent for human-made sources. The team observed no visual disturbance, just a soft harmonic drone that faded as quietly as it began. Some suggest gas seeps beneath the dunes may be responsible. Methane bubbles slowly rising through sediment could trigger micro shifts in sand layers, releasing tension in bursts that resonate like a plucked string. Others believe it could be tied to microismic activity, minute tremors reverberating through loose sediment in ways not yet fully understood. But what's particularly puzzling is the musical quality of the sound. It's not just noise. It has pitch, sometimes even intervals. The ocean in these rare moments seems to hum in a tone that mimics intention, a sound that resonates not just in instruments but in the imagination. Of course, in the absence of clear answers, speculation begins. Some have proposed that the phenomenon could be evidence of subsurface movement, massive sediment flows, or slow tectonic shifts too subtle to register as quakes, but significant enough to alter the acoustic landscape. Others wonder if there are natural cavities, vast underwater voids beneath dune fields where trapped gases or sudden collapses could produce tonal vibrations. And then there are the stranger theories. A few fringe voices suggest these underwater tones might be remnants of something older, long dormant mechanisms or natural resonators shaped by time, erosion, and coincidence. The idea that certain rock or sand formations, when disturbed, could function like enormous accidental musical instruments. Even the notion, however unlikely, that these might be communication signals of a kind we simply haven't learned to decode. There are no confirmed maps of all the world's underwater dunes. Many of these sandy landscapes lie in areas difficult to access, subject to strong currents, sudden pressure changes, and logistical limitations. Each one is shaped by its own geological history, making them difficult to classify or compare. We know they exist, we know they move, but we don't always know how or why they sound the way they do. So far, only a handful of these mysterious songs have been captured by scientific instruments. Most have come to us through anecdote, divers surfacing with wide eyes and uncertain words, researchers pausing as the seafloor beneath them hums with no apparent source. What triggers these resonances? What other tones might be humming across the deep ocean floor just beyond the range of our perception? And perhaps more intriguingly, if nature has found a way to sing in the desert and under the sea, what is it trying to say? From the resonant hum of singing sand dunes deep beneath the sea, where nature seems to speak in tones we barely understand, we now turn to a sound unlike any other, a sound not felt through the body, but captured in the silence of data, a sound that traveled across the vastness of the Pacific Ocean, a sound known only as the bloop. It was 1997, the National Oceanic and Atmospheric Administration, or NOAA, was conducting acoustic monitoring in the South Pacific using a network of underwater microphones, hydrophones originally designed to track submarines during the Cold War. These sensitive instruments spaced thousands of kilometers apart were now being used to study seismic activity, whale migration patterns, and the subtle pulse of the deep. Then one day in late summer they picked up something unexpected, a deep, powerful, low-frequency sound, a strange gurgling followed by a swelling surge, rising in pitch, fast and sudden, as if something impossibly vast had moved, somewhere deep in the ocean. The sound was so loud it was recorded by multiple hydrophones more than 3,000 miles apart. It echoed across the Pacific, and yet no ship had reported it. No earthquake was logged, no volcanic eruption occurred. The coordinates traced the origin to a remote stretch of ocean west of South America near Antarctica, far from human activity, far from anything at all. The sound was dubbed the bloop. At first, NOAA scientists were mystified. The signature bore some resemblance to known marine animals, but the volume was orders of magnitude greater than anything ever recorded. For context, the loudest known animal of the blue whale can produce vocalizations around 180 dB, but the bloop was far louder. If it came from a living creature, that creature would need to be far larger than a whale, much larger. The bloop quickly moved from scientific circles into public fascination. The idea of an unknown species, something hidden, something ancient lurking in the cold, dark waters of the Southern Ocean captured imaginations. Articles and documentaries speculated about enormous undiscovered animals. Writers compared the location to the coordinates of Relia, the fictional sunken city described by H.P. Lovecraft, a coincidence that was impossible to ignore for fans of cosmic horror. But beneath the speculation, the core mystery remained. If it wasn't biological, what was it? In the years that followed, researchers explored other possibilities. One leading theory suggests that the bloop may have been caused by cryosism, a phenomenon where large icebergs crack or split apart. As massive chunks of ice cave from the Antarctic shelf or collide with one another, they can produce seismic and acoustic signatures that resemble organic sounds. It's plausible. Many scientists now believe that the bloop was simply the echo of ice in motion, a natural sound amplified by the conditions of the deep ocean. And yet questions linger. Unlike other iceberg sounds captured since, the bloop had an unusual acoustic profile. It was more tonal. It rose in pitch. It echoed in ways that didn't perfectly match the known dynamics of icequakes, and its clarity, so strong, so far-reaching, made it stand apart from more common glacial events. Some experts remain unconvinced by the ice theory. Others acknowledge the match, but not with complete certainty. There's another curious detail. The bloop has never repeated. Not once in the decades since has a sound of the same intensity and character been recorded. If it were caused by natural ice activity, one might expect similar events to recur. Some have, but none have sounded quite like this. Then there is the matter of scale. For the bloop to be produced by an animal, that animal would need to be something beyond our current biological models. Not just large, but mythic. Something with lungs or chambers capable of generating sound through kilometers of water. The idea strains credibility, but it also invites wonder. Could there be life in the deepest parts of the ocean, evolved to sizes and forms we have not yet encountered? Could a creature live so deep, so slow, and so rarely moving that it eludes every sonar sweep and satellite scan? We've explored only a fraction of the ocean floor. Vast trenches remain unmapped. Entire undersea mountain ranges have only recently been discovered. In that uncharted space, the improbable is not impossible. It is simply unknown. And what if the bloop was not just a singular event? What if it was a signal, not an accident? Could it have been the sound of movement, of something waking, or perhaps something collapsing deep within the Earth's crust, where tectonic and oceanic forces converge in ways we do not yet understand? The bloop has now joined a small catalogue of unexplained underwater sounds. The upsweep, the slowdown, Julia. Each with their own signature, each with their own theories, and none with definitive explanations. Each time we listen to the deep, it seems we hear echoes of something just beyond our reach. So what then was the bloop? A cracking iceberg amplified by underwater acoustics, a previously unknown geological event, or a trace of something living, massive, and rare, passing briefly through the edge of our awareness? We may never know. But somewhere beneath the surface of the Pacific, where the water is black and the pressure crushes metal, the bloop rang out once and was gone. A single breath in a world of silence, a ripple in the deep, and perhaps one day it will return, or perhaps it never left. The ocean has a voice, not loud, not constant, but occasional, fleeting like whispers caught in a storm. And just as the mystery of the bloop echoed across the Pacific with impossible force, and then vanished, another sound was heard, not as loud but equally strange, equally unexplained. It came to be known simply as Julia. On March 1st, 1999, NOAA's hydrophone array, a system of deep-sea microphones scattered across the Pacific, picked up a long, low, moaning sound. It lasted for roughly 15 seconds, an eternity in acoustic terms. It began softly, then rose in volume, wavering just slightly in pitch, like something ancient groaning under pressure. The sound was distinctive, haunting, and again, like the bloop. It was loud enough to be picked up by multiple listening stations thousands of kilometers apart. The source was triangulated to a remote region between the Bransfield Strait and Cape Pedare, near the coast of Antarctica, a cold, desolate stretch of sea where icebergs drift aimlessly and the seafloor plunges into unmapped trenches. No ships were nearby, no known undersea eruptions were recorded, and no whales, at least none we know of, make sounds like this. Julia, a name that evokes softness, familiarity. But in this case, it names a sound that has no clear origin and no certain cause. A sound that to this day remains unexplained. The first theories, as always, lean toward the geological. Some researchers believed the sound could be attributed to an ice quake, a phenomenon where massive icebergs grind against the seafloor or collide with other frozen masses, producing low-frequency acoustic signatures. These events are not uncommon near Antarctica, and in some ways, Julia fits the profile. It's deep, long, and resonant. But there were differences, subtle ones. Julia's tone was unusually smooth, more fluid, more organic. Unlike the fractured burst of a cracking glacier, it was almost melodic, continuous. Some described it as a wail, others as a mechanical sigh. One researcher, off the record, compared it to a distant engine idling beneath the waves. The kind of noise that feels purposeful, though no one knows why. The most compelling detail: a few weeks after Julia was recorded, a classified US satellite reportedly captured a large shadow moving through the same stretch of ocean. The image was never released. The object, if there was one, was never officially identified. The correlation may be meaningless, a coincidence, a trick of timing, but in a place so empty, so remote, it's hard not to wonder. Was Julia the sound of something moving? Some have speculated that the sound could have been created by submarine activity, a classified test, a piece of military technology drifting beneath the surface. Yet, even this explanation struggles to account for the acoustic profile. Julia didn't reverberate with the sharp, angular echoes of machines. It sounded older, deeper, more natural, or perhaps more unnatural. Then there are the fringe theories that Julia was produced by an unknown life form, a massive, deep-sea creature passing through one of the most isolated parts of the Southern Ocean. A creature capable of generating sound at an enormous scale, one whose biology and behaviors remain entirely outside our current knowledge. These ideas aren't widely accepted in scientific circles, of course, but they're not dismissed out of ridicule, only out of caution, because the fact remains. We know more about the surface of Mars than we do about the Southern Ocean floor. In those frozen waters, beneath the drifting ice shelves and hidden ridges, are vast areas never touched by a research submersible. Entire ecosystems may remain undocumented, and what lies within them, living or not, is still a mystery. Unlike the bloop, Julia has not recurred. It was a one-time event, a voice that spoke once in 1999 and then was silent, but it was enough to raise questions, enough to stir curiosity in those who spend their lives listening to the ocean. What kind of force can produce such a sound so large, so low, so haunting? What structure or substance must shift or move or resonate to cry out across thousands of miles of open sea? Could it have been a collapsing cavern beneath the seafloor? A release of gas trapped under ancient pressure? A cascade of ice breaking free and falling into the abyss? Or could it have been something else entirely? Something alive or once alive sounding off in a part of the world where almost no one is listening. Julia remains unconfirmed, unverified, unexplained. A lonely entry in the catalogue of deep-sea anomalies with no obvious culprit and no repeat performance. But maybe that's what makes it linger. It reminds us that the ocean is not silent, that beneath its surface, strange things still happen. Sounds without sources, movements without explanation, whispers without words. And in the cold southern waters, somewhere near the edge of the Antarctic shelf, Julia still echoes, if only in memory. What made that sound? And what else lies beneath, unheard? We listen, we wait, and the deep ocean, as always, keeps its secrets. As the echoes of Julia fade into the icy silence of the southern seas, another voice rises from the depths. Less sudden, more rhythmic, yet equally untraceable. A sound not heard just once, but over and over again for decades. Persistent, unrelenting. This is the Upswept, one of the ocean's longest running sonic mysteries. It was first recorded in 1991 when NOAA's Pacific Marine Environmental Laboratory began continuous underwater monitoring using a system of long-range hydrophones scattered throughout the Pacific. Almost immediately, they detected something unusual. A repeating series of sound pulses, each one distinct, lasting several seconds, rising in pitch in a slow ascending pattern, like a siren winding up like something warming or waking. The sound came not from a single point, but from a broad region in the central Pacific Ocean near volcanic activity along the Pacific Plate boundary. And while the exact source has never been pinpointed, its signature was unlike anything scientists had encountered before. The upsweep repeats at irregular intervals, often increasing in activity during certain times of the year. Sometimes it's louder, sometimes it fades to near silence, but it never disappears. Over 30 years later, it continues and no one knows what causes it. Unlike the bloop or Julia, brief, singular events, the upswept presents a different kind of puzzle. It is a long-term phenomenon recorded across multiple decades, displaying consistency and pattern. The sound itself consists of clusters of narrow band upsweeping tones, each one lasting several seconds and arranged in repeating bursts. When visualized, the frequency rises like a staircase, hence the name, the upsweep. Its location, deep in the Pacific, offers limited clues. The Central Pacific is home to undersea volcanic ridges, seamounts and tectonic boundaries, places of constant geological motion. One prevailing theory is that the upsweep is generated by volcanic activity, perhaps by the movement of magma or the release of gases from deep beneath the seafloor. As hot magma rises through rock, it can cause pressure waves to ripple through surrounding water. If the movement is rhythmic due to geological cycles or fluid dynamics, it could produce sound patterns like those of the upsweep. But if that were the case, why has no eruption ever been associated with it? Why does the sound persist without corresponding seismic events? And why does it seem to intensify and fade in seasonal patterns? Some have suggested a link to temperature shifts, perhaps thermal expansion in underwater rock as ocean conditions change. Others propose the sound might be related to hydrothermal venting, the release of superheated fluid from fissures along the seafloor. These vents can be highly active and under the right conditions could generate low-frequency noise, yet no vent has been found at the source of the upsweep. No plume, no visible disturbance. The sound also bears no resemblance to known marine life. Whale songs, for example, are well documented, ranging across frequencies and rhythms, but none produce consistent upsweeping tones of this nature. And while some deep-sea creatures generate sonar-like clicks or pulses for communication or navigation, their signals tend to be brief, erratic, and far weaker than the massive sound signature of the upsweep. There are inevitably more speculative ideas. Some have wondered whether the upsweep might be an artifact of human activity, a long-range sonar test, a deep-sea mining experiment, or even a cloaked military operation. But no government has claimed responsibility. And the sound's behavior, particularly its seasonal variability and longevity, seems inconsistent with mechanical sources. Others take a more unconventional view. Could the upsweep be a biological phenomenon, something we've never observed directly? Perhaps a deep-sea species that operates on cycles unknown to us, emitting sound as part of migration, mating, or territorial behavior. If such a creature exists, it would be unlike anything in the current biological record, and it would be vast. A few have even speculated that the upsweep could be an automated pattern. Not alive, not mechanical, but something in between. A kind of natural system acting on geological or chemical triggers, repeating its cycle in silence for millennia, like a clock ticking away in the deep. And yet, no conclusive evidence has emerged. We still don't know what produces the sound. We don't know why it intensifies in the spring and fall, or why it's been growing fainter in recent years. Perhaps the source is dying, or perhaps it's simply receding, slipping further below the noise floor, out of reach. The ocean is vast and sound travels far. A low-frequency signal like the upsweep can travel thousands of miles through what scientists call the SOFAR channel, a deep layer of water that acts as an acoustic superhighway. It's possible the origin is not where we think. It may be echoing from afar, distorted by time and pressure. What we do know is that it's still there. Somewhere in the Pacific, below the waves, a sound continues to pulse, repeating, climbing, vanishing, returning. What is it we're hearing? The breathing of the earth, the voice of something unseen, or simply a natural process too large and slow for us to yet comprehend? The upsweep reminds us that not all mysteries make themselves known in dramatic moments. Some simply persist, quietly, steadily, whispering through the darkness. And somewhere, deep beneath the sea, that whisper continues still. As the mysterious rhythm of the upsweep fades into the depths of the Pacific, we turn our gaze not to a sound, but to a creature, one just as elusive, just as haunting. A presence known more by absence, by scars, and by scattered fragments than by observation. Something massive, something intelligent, something we still barely understand. This is the colossal squid, Masonicotus hamilton, a species so rarely seen that it borders on mythical and yet so real that it leaves behind hooks the size of kitchen knives and eyes larger than a human head. The Southern Ocean encircling Antarctica with its icy embrace is the home of this giant. It is a place of perpetual cold, deep darkness, and crushing pressure, an environment perfectly suited to things that live hidden. Here, in the bipelagic zone, where sunlight has never reached, the colossal squid drifts silently, not hunting by sight but by sense, not fleeing or chasing, but waiting, watching. Though long feared and fabled, the colossal squid wasn't officially identified until 1925, when 2 of its tentacles were discovered inside the stomach of a sperm whale. Since then, only a handful of specimens have been recovered, most of them dead, washed ashore, trapped in fishing nets, or pulled from the bellies of deep-diving predators. The largest known specimen measured an estimated 14 meters or 46 ft from the tips of its tentacles to the end of its mantle. But it's not just the size that captivates scientists, it's the anatomy. The colossal squid possesses rotating hooks on its tentacles. These are not simple suckers or claws. These are swiveling barbs capable of slicing and anchoring into flesh with terrifying precision. Its eyes are the largest of any animal ever recorded, over 30 centimeters across, roughly the size of a dinner plate. These eyes are adapted to detect bioluminescence in pitch-black waters, allowing the squid to sense the faintest glimmer of nearby life. But for all its biological extremity, its behavior remains a mystery. Unlike the more famous giant squid, which tends to dwell at slightly shallower depths and has been filmed alive in recent years, the colossal squid has never been observed in its natural habitat. We do not know how it mates, how it feeds, or how it interacts with others of its kind. Its life cycle, its migration patterns, its reproductive habits, all of it remains almost entirely speculative. What little we do know comes from inference. From the marks left on whales, massive suction scars, and deep gouges found on the hides of sperm whales who venture into the same depths. These battles fought in the dark tell us that the squid does not always flee, that sometimes it defends itself, that perhaps it even fights back. The presence of ammonium chloride in its tissues gives it buoyancy, allowing it to float motionless in the water, conserving energy in the cold. It likely uses ambush as a hunting strategy, lurking, waiting for prey to come near before launching forward in a sudden, explosive strike. But how often does it feed? How does it find a mate in the vast, empty darkness? Are they solitary hunters? Or do they ever gather in unseen masses in deep crevices or undersea plateaus? And perhaps more curiously, why are they so rarely seen? Despite decades of technological advancement in deep-sea exploration, sightings of colossal squid remain vanishingly rare. Most specimens are discovered only by accident, and although we have advanced submersibles, robotic cameras, and sonar arrays, none have yet captured these creatures alive in their element. It's as though they exist just beyond the edge of our reach, slipping away when the lights come on. This absence has led to speculation. Some scientists have wondered whether the colossal squid is simply more intelligent than we expect, capable of sensing the approach of foreign objects and avoiding them. Cephalopods, after all, are known for their high intelligence, problem-solving skills, and adaptive camouflage. Could the colossal squid possess a kind of deep-sea cunning that helps it remain hidden? Others ask whether the colossal squid may be just one representative of a group of related species we've yet to discover. Could there be even larger, stranger relatives living deeper still in the unmapped trenches of the Southern Ocean? Is the colossal squid the apex of its kind, or just a glimpse of something older, bigger, and even more elusive? Fringe theories speak of cryptid giants, ancient creatures that inspired sailor legends like the Kraken, beasts of impossible size that still dwell in the ocean's last untouched places. While these ideas stretch the bounds of biology, they remind us how little we truly know about the creatures that live where no light falls. And then there's the philosophical question. If something that large, that extraordinary, can remain almost entirely hidden in our modern world, what else might be out there? We've sent machines to Mars, we've mapped the moon's surface in high resolution, but the deep ocean remains largely unexplored, a dark frontier where colossal things move without sound, live without light, and vanish without explanation. The colossal squid remains an enigma, a life form at the edge of human knowledge, a creature seen only in death, imagined only in fragments. But it is real. And perhaps someday, in the cold stillness beneath the ice, we will see it as it lives, not just drifting or dead, but hunting, watching, or waiting. What does it know of us? And what do we still have to learn from it? In the shadows of the sea, some truths are too large to ignore and too well hidden to find. As the colossal squid slips back into the obscurity of the abyss, we surface slightly, but only just. Not to the sunlit shallows, but to the twilight zone of the sea, where shapes drift like ghosts and shadows stretch unnaturally long. Here, in the dim blue hush of the mesopagic layer, another legend moves with slow, undulating grace. Long serpentine, almost unreal. This is the giant oarfish, the world's longest bony fish and the living inspiration behind countless tales of sea serpents and monsters. A creature that when seen seems less like an animal and more like a myth, come to life with a body that can stretch over 11 meters, more than 36 et. The giant oarfish glides through the water like a ribbon caught in a breeze. It is silvery, with a metallic sheen that reflects the faintest light. Its long dorsal fin, which runs the length of its body, pulses gently as it moves vertically through the water. Head up, tail down, in a posture rarely seen in marine life, and atop its head, a crown of bright red fin rays fan backward like some ancient crest. Regal, otherworldly. Most people never see one alive. The vast majority of oarfish sightings happen only when they wash ashore, already dead or dying, sprawled on beaches in Japan, New Zealand, the Philippines, or the western coasts of the Americas. These strandings are rare, but when they happen, they ignite fascination, not just because of the creature's size, but because of what it seems to suggest. Where do these beings come from? Why do they appear so suddenly and so seldom? The first scientific documentation of the giant oarfish came in the late 18th century, but fishermen and sailors had been describing them for centuries. In Japan, they're known as Ryugu no Sakai, or messengers from the sea god's palace. In local folklore, their appearance is a harbinger of disaster, a warning of earthquakes, tsunamis, or deep-sea disturbances yet to come, and the timing has raised eyebrows. In 2010, several oarfish were found washed up in Japan just months before a series of undersea quakes struck the region. In 2013, more washed ashore in the years leading up to the massive Tohoku earthquake and tsunami. Scientists caution against drawing causal links. There is, they say, no known mechanism that would allow oarfish to predict seismic activity. But still, the pattern persists, and with it, the questions. Could these deep-dwelling fish, which typically live between 200 and 1,000 hours below the surface, be responding to shifts in the Earth's crust? Could they be sensitive to vibrations or pressure changes in ways we don't yet understand? Biologists suggest more grounded explanations. Oarfish, like many deep-sea creatures, are delicate. Sudden changes in temperature, salinity, or water currents can disorient or fatally stress them. Some scientists believe that undersea landslides, upwellings, or even algal blooms could disturb their habitat, forcing them into shallower waters where they cannot survive. But that doesn't fully explain the consistency or the uncanny timing of their appearances, nor does it explain their behavior when found alive. In the few documented cases where oarfish have been observed swimming near the surface, they behave strangely, slow, disoriented, almost entranced. In 2017, a pair of divers off the coast of Baja, California, encountered a living oarfish drifting upright in open water. Its long body shimmering, its fins waving gently in rhythmic motion. It made no attempt to flee. It simply hovered, as if unaware of their presence or indifferent to it. Some have speculated that such behavior could be part of a reproductive ritual. Others wonder whether they come to the surface in death, not life, rising only as a final act driven by instinct or confusion. And some suggest that we are only seeing these animals when they are already unwell. Their strange movements not a window into normal behavior, but a symptom of decline. And yet, the more we learn, the more questions seem to emerge. Because the truth is, we know remarkably little about oarfish. We don't know how often they breed or where. We don't know how long they live. We don't know what they eat in the deepest parts of their range, or how they navigate the vast underwater deserts they inhabit. Almost all of our information comes from carcasses, surface-level observations, or isolated encounters. And when something so large, so distinct, and so unmistakable remains largely invisible in a world we believe we understand, it's a reminder of how much lies hidden just below. Could oarfish be more common than we think, simply living lives so far removed from ours that their presence is rarely detected? Or do they dwell in places we haven't yet explored, ridges, trenches, or thermal layers where observation is nearly impossible? Or perhaps they are in some way connected to shifts in the Earth, not as mythical messengers, but as biological sensors, creatures tuned to pressures and pulses far beyond our senses. We can't say for sure, but when a ribbon of silver appears on the shore, shimmering like moonlight and crowned with crimson, it's hard not to feel that something ancient has surfaced. If only for a moment, a glimpse, not just of a creature, but of a mystery. And somewhere beneath the sway of the ocean's surface, more of them move silently, gracefully, unseen, waiting. From the elusive drift of the giant oarfish, those ethereal messengers from the deep, we descend once more beyond the reach of sunlight, into a world shaped not by the moon and tide, but by the Earth's ancient volcanic breath. Here, at the junctions of tectonic plates and deep ocean ridges, towers rise from the seafloor. Dark, jagged chimneys surrounded by curtains of swirling black water. They seem to breathe, exhaling dense, mineral-rich plumes into the freezing abyss. These are the black smokers. They are not structures built by human hands, nor ruins of any ancient civilization, but natural vents, hydrothermal openings in the Earth's crust that spew superheated water into the ocean depths. And yet, there is something strangely architectural about them. Some rise several stories tall, sculpted by years of mineral buildup. Their spires twist and branch like the towers of a forgotten cathedral. Their surfaces glisten with metal sulfides and strange organic textures. Around them, the sea glows faintly with heat and life. Black smokers were first discovered in 1979 near the Galapagos Rift by a team of researchers using the deep-diving submersible Alvin. Until then, no one had suspected that such heat, such chemical activity, and most shockingly, such vibrant life could exist at such crushing depths in total darkness. The water that erupts from these vents can reach temperatures of 400 degrees at sea, hot enough to melt lead, yet remains in liquid form due to the immense pressure of the deep ocean. As it emerges from beneath the seafloor, this fluid is laced with dissolved minerals, iron, copper, zinc, and sulfur. When it meets the near-freezing seawater, it rapidly cools and the minerals precipitate, forming the dark smoke that gives these structures their name. But the smoke is only part of the story. Around these vents, ecosystems flourish in utter defiance of everything we thought we knew about life. Tube worms over a meter long with blood-red plumes, pale crabs with fur-like bristles, ghostly eels and shrimp with no eyes. These organisms don't rely on photosynthesis. There is no sunlight here. Instead, they live through chemosynthesis, a process in which bacteria convert the chemicals emitted by the vents into energy. This discovery shattered a long-standing assumption that all life on Earth ultimately depends on the sun. But here in the blackest waters on Earth, life is built on chemical fire. And it raises a question. If life can emerge here without light, without plants, without oxygen, could it exist elsewhere in the universe under similar conditions? The environments around black smokers are often cited as potential analogies for alien ecosystems on moons like Europa or Enceladus, where oceans lie hidden beneath thick layers of ice and tidal forces generate internal heat. If hydrothermal vents exist there, and some data suggests they might, then the possibility of life, however simple or strange, becomes far more tangible. But black smokers pose mysteries even closer to home, despite their hostile perhaps of things yet to come. Could the key to life's beginning lie in their rising plumes? Or do they lead deeper still to places we have not yet dared to look? The ocean holds its secrets tightly, and the black smokers, like ancient sentinels, keep watch in the dark. As the towering black smokers exhale their mineral breath into the crushing dark, we drift outward away from their molten core into the quiet open sea. Here in the vast mid-water depths, the silence thickens, the pressure deepens, and the darkness becomes absolute. Yet even here, something stirs. In the blackness, light blooms, soft, flickering blue, green, violet, brief pulses and sudden flares, tiny sparks like embers drifting in the cold, slow ripples of pale radiance winding through the water like living constellations. This is the realm of deep-sea bioluminescence, a phenomenon both haunting and beautiful, where life has found a way to create its own light in the absence of the sun. In the meopelagic and bipelagic zones, hundreds, perhaps thousands of meters below the surface, more than 75% of marine organisms are believed to exhibit some form of bioluminescence, from drifting jellyfish and glowing squid to delicate comb jellies and single-celled plankton. The deep ocean is alive with light we can scarcely imagine. But this light is not decorative. It is functional, strategic, and in many cases still mysterious. The glow is produced through chemical reactions, usually involving luciferin, a light-emitting molecule, and luciferase, an enzyme that acts upon it. But the ways in which these reactions are triggered, modulated and evolved vary widely between species. Some creatures can flash suddenly, others emit a steady glow. Some project their light outward, others turn it inward, lighting up their own organs, skin or surroundings. But why? What is light in a world of total darkness? Some use it to lure prey. The deep-sea anglerfish, with its infamous lure, a bioluminescent tip dangling just above its mouth, attracts curious fish straight into its jaws. Others use light for camouflage. The hatchetfish, for example, produces light on its underside to match the faint illumination filtering down from above, rendering itself invisible from predators lurking below. Some flash to confuse or distract, releasing bursts of light to blind attackers or create the illusion of movement elsewhere. Others eject glowing clouds of chemicals like underwater smoke bombs before slipping away. A few species even use bioluminescence for communication, sending out rhythmic pulses in courtship dances or warning displays. But there are examples that defy easy classification. Some creatures glow constantly, even when no threat is present. Others emit light in patterns or sequences that seem too complex for simple survival. Deep-sea siphonophores, colonial organisms that can stretch for meters, pulse with coordinated light that flows along their bodies in waves. What purpose does this serve in a place where few would witness it? In some of the deepest trenches where food is scarce and mates are rare, researchers have observed strange bioluminescent flashes, brief, intense, and isolated. No organism was identified. No known animal could have produced such a signal from that depth in that location. Were these byproducts of unseen predators or signs of something yet unclassified? And then there are the so-called blink storms, phenomena in which huge swaths of the deep sea suddenly erupt in bioluminescent pulses like underwater lightning storms. These events are rare, spontaneous, and poorly understood. Some have been captured on camera during submersible dives, others only recorded via distant light sensors. Could they be coordinated? Are they triggered by seismic events, migratory behavior, or something else? Bioluminescence has evolved independently dozens of times in marine life. It appears in bacteria, fungi, plankton, fish, cephalopods, and more. But why has this trait become so widespread in the ocean and almost entirely absent on land? What unique pressures, environmental or evolutionary, made light such a useful tool in the deep? Some scientists believe it points to a common need for communication in the dark. Others suspect that bioluminescence plays roles we haven't yet recognized, perhaps even in navigation, energy storage, or microbial balance. And the more we study it, the more unusual it becomes. In 2019, researchers exploring the Gulf of California captured footage of a jellyfish emitting two distinct types of light, one pulsing in short blue bursts, another glowing red. The red bioluminescence was particularly strange, as red light does not travel well underwater and is rarely produced in marine animals. Was it a mating signal? A private channel of communication visible only to specific eyes. Elsewhere, researchers have discovered bioluminescent bacteria living not just on but inside other organisms. Some squids have built-in light organs that resemble eyes, complete with lenses, reflectors, and shutters. These organs house colonies of bacteria that produce the light, while the squid controls its direction and intensity like a biological flashlight. Are we looking at the beginning of a deeper symbiosis, a shared intelligence between host and microbe? And beyond that, if organisms can control light internally, could they also manipulate it externally? Could they cast shadows, mimic other shapes, or project illusions in the water? Bioluminescence in the deep sea is not just a curiosity. It is a language, a tool, a survival strategy honed over millions of years in the most hostile environment on Earth. But much of it remains hidden, seen only in brief moments, captured in low resolution by distant cameras or observed out of context. We are still deciphering the grammar of this strange language, still struggling to understand what these lights mean to those who use them. What messages are being passed unseen in the darkness? What secrets glow just beyond our reach? The deep sea is not silent. It is not empty. It shines softly with the stories of lives we have yet to know. As the bioluminescent twilight of the deep sea pulses and fades, we journey deeper still into the oxygen minimum zone, a realm suspended between the better-known regions of the ocean. Not quite the lightless trench, not quite the nutrient-rich shallows. It is a place of paradox where life exists under conditions that should be too hostile to support it. Here in this dusky borderland drifts one of the ocean's most enigmatic creatures, a being with the name of a monster, but the habits of something far stranger. A creature with glowing eyes, a cloak of webbed arms, and a body built not for speed or aggression, but for stillness. This is the vampire squid. Vampiritus infernalis, literally translated as the vampire squid from hell. And yet, despite the name, there is nothing overtly hellish about it. It is not a predator. It does not suck blood. It is in fact more ghost than vampire, more observer than hunter, a drifting shadow perfectly adapted to an environment where almost nothing else can live. At first glance, the vampire squid resembles something out of science fiction. Its soft, gelatinous body measures less than a foot long with 8 arms connected by a deep webbed cloak. Its skin ranges from deep red to black, and its enormous eyes relative to its body gleam blue in the dark, making them some of the largest eyes proportionally in the animal kingdom. Unlike true squids or octopuses, it belongs to its own evolutionary branch, neither one nor the other. A relict species, it sits alone on its branch of the tree of life, unchanged for millions of years. A living fossil from a time when the seas were ruled by creatures we scarcely recognize. Its biology is no less strange. The vampire squid doesn't chase prey. It floats, drifts, waits. With a body low in density and rich in ammonia, it is neutrally buoyant in the water column. Its metabolism is slow, very slow, allowing it to survive with little oxygen in regions of the ocean where most fish, squid, and invertebrates would quickly suffocate. It doesn't need to feed constantly. Instead, it consumes what few others do. Marine snow, a soft rain of organic debris falling from above. Dead plankton, fecal matter, decaying jellyfish. The vampire squid gathers these particles with two long retractable filaments, structures unlike any found in other cephalopods. They stretch outward, collecting the drifting matter like a net, then draw it in where it is coated in mucus and passed to the mouth. It's not the image we associate with cephalopods, those jet-powered hunters and color-shifting predators. The vampire squid is different. Its survival is not based on speed or stealth. It survives by doing almost nothing, by minimizing energy, by remaining still. And yet, it has evolved one of the most dramatic defense mechanisms in the ocean. When threatened, the vampire squid inverts itself, turning its arms inside out over its body, pulling its webbed cloak over its head to reveal the black interior and rows of spiny projections. These spines are not dangerous, not rigid. But in the darkness their sudden appearance makes the squid look far larger, far more threatening. Simultaneously, it releases clouds of bioluminescent mucus, a glowing, particle-filled veil that confuses predators and illuminates the attacker rather than the squid. This is no ink cloud in the traditional sense. It is a glowing decoy, a ghost light that drifts and swirls, buying precious seconds to escape. No other cephalopod exhibits this kind of defense, and it raises questions about how the vampire squid evolved such unique adaptations, not in the presence of constant threat, but in a zone with very few predators. Why develop such elaborate behavior in such a quiet, energy-starved place? Even more puzzling is its solitary existence on the evolutionary tree. How did this creature survive mass extinctions? Climate shifts and changing ocean chemistry while so many of its relatives vanished? What allowed it to persist, unchanged in the middle layers of the ocean for tens of millions of years? And if it is a relic from the past, what else might it remember? In recent years, researchers have begun to wonder whether the vampire squid might be more common than we assumed, simply overlooked due to its habitat. It rarely comes near the surface, and its gelatinous form makes it nearly invisible to sonar. It leaves no lasting mark on the environment, no bones, no trail, only brief, glowing encounters caught on camera by deep-sea ROVs. But could it be part of a larger web, a hidden ecosystem living within the oxygen minimum zones of the world's oceans? A system of slow-drifting ancient life adapted not to dominate, but to endure? And what might these creatures know biologically, evolutionarily, about long-term survival in a world of diminishing resources? The vampire squid challenges our assumptions not just about marine life, but about what it means to survive. It is not efficient in the traditional sense. It is not fast, not powerful, not dominant. But it is still here. And as we continue to probe the dim layers of the ocean, seeking movement, light, and explanation, it remains just out of reach, drifting between visibility and obscurity. Ancient, undisturbed, a presence, not a threat, a whisper, not a roar. And so we wonder what else drifts between the layers, unseen, unchanging, and waiting to be understood. From the silent drift of the vampire squid, with its ancient lineage and ghost-like stillness, we now enter a stranger realm. Still one where transparency replaces armor, and the boundary between creature and environment begins to blur. Here, deep in the ocean's twilight zone, swims one of the most bizarre, least understood fish on Earth, a fish with a transparent head, glowing green eyes, and a motionless stare that seems to pierce through the darkness. This is the barrelly fish Macropina microtoma, a deep sea marvel that challenges everything we thought we knew about evolution, perception, and survival in the ocean's most alien layer. Found between 600 and 800 meters below the surface, the barley is a small fish measuring only about 6 in long. But what it lacks in size, it more than makes up for in strangeness. Its body is sleek and dark, built for low energy cruising through still waters. But the real mystery lies in its head, a soft, dome-like gelatinous structure that is completely transparent, allowing a clear view of its internal anatomy. Inside this dome are two barrel-shaped tubular eyes, bright green and eerily luminescent, pointing straight upward, like searchlights aimed at the ceiling of the world. For decades, researchers believed these were fixed in place, but recent observations have revealed that the eyes can rotate within the transparent shield, allowing the fish to look forward when hunting. The effect is surreal. Through the glassy dome of its head, you can see its eyes move, tracking prey, adjusting position, staring through its own skull into the dim waters above. But why would any creature evolve such a design? The prevailing theory is that the barrel uses its upward-pointing eyes to detect the faint silhouettes of prey, usually jellyfish, small crustaceans, or drifting marine snow against the minimal light filtering from above. In a region where most predators look forward or downward, the barley's vertical gaze offers a unique advantage. It hunts by watching the sky. The transparent dome itself serves a purpose as well. It acts as a protective shield, buffering the sensitive eyes from the stinging tentacles of jellyfish, which form a large part of its diet. Some scientists suggest that this structure might also reduce distortion from light refraction, giving the fish clearer, more accurate visual input in an environment where every photon counts. Still, the design is so strange, so unprecedented that it raises questions. Why has this visual system evolved in only this one species? Could there be other creatures similarly adapted that we simply haven't encountered yet? Either because they dwell even deeper, or because they are too fragile to survive our methods of observation. The Borelli wasn't observed alive until 2004. Before that, every specimen ever collected was damaged during capture, its delicate head structure collapsing under pressure or net impact. For decades, scientists knew of the fish only as a shadow of itself, and its true form was unknown. It wasn't until remote-operated submersibles captured footage in the deep that we finally saw it as it is, intact, alive, and impossibly strange. Its movements are slow and deliberate. It hovers motionless in the water column, held aloft by fins that seem to glide rather than flap. It does not dart or chase. It waits, motionless, rotating its eyes as it scans the dim ceiling of its world. When it sees something worth catching, it adjusts its gaze forward and rises slowly to intercept. It is a method not of aggression, but of patience. A lifestyle defined not by strength, but by stillness. And yet, despite these insights, much remains unknown. How often does the barley feed? Does it live alone or in scattered schools? What other sensory mechanisms does it use in an environment so devoid of sound and light? And how does it reproduce? No mating behaviors have been observed. No nests, no eggs, its life cycle, its migration, even its predators are still largely a mystery. And then there's a broader question. How many other animals have we misunderstood, seen only in pieces or after death, their delicate structures collapsed or unseen? How much of the ocean's life remains not only undiscovered, but misunderstood because we've only glimpsed it through the wrong lens? Some fringe speculations go further. A few researchers have floated the idea that the barley's adaptations could allow it to detect more than just light, perhaps even bioluminescent trails, faint chemical emissions, or subtle distortions in water pressure. Could its gaze, so focused, so alien, be tuned to a layer of the environment we don't yet understand?
Others point to the eerie, almost surveillance-like quality of its gaze, a creature that lives by watching, that sees silently from behind a shield without being seen in return.
What exactly is it watching for? Of course, these questions remain speculative, but the barrel invites them. Its very existence is a challenge to simplicity. It is not beautiful in any traditional sense. It is not fierce or fast. It is something else, a quiet sentinel adapted to a realm of shadows, surviving in ways we are only beginning to grasp. And so it floats alone in the blue-black quiet, eyes raised toward the light, transparent, strange, and waiting. What else in the hidden layers of the ocean is watching us in return? As the barrelfish hovers motionless in the twilight sea, peering upward with its transparent gaze, we drift down once more into deeper waters, darker realms. Here, in the benthic quiet of the deep sea, among canyons and ridges formed long before humanity stood upright, moves a creature that feels misplaced in time. It swims with the slow, undulating motion of something ancient, its body long and serpentine, its mouth wide and filled with rows of needle-like teeth, its skin rough, almost wrinkled like old leather, its eyes dark and inscrutable. This is the frilled shark. Clementelicus anguus, a creature so primitive, so unchanged that it's often described as a living fossil. Measuring up to 2 meters in length with a body that more closely resembles an eel than a modern shark, the frilled shark gets its name from the 6 pairs of gill slits that run down the sides of its throat, each trimmed with ruffled frill-like edges. It possesses a long, narrow head and an oddly flexible jaw capable of extending outward to seize prey. Inside its mouth are over 300 backward-facing teeth arranged in 25 rows, perfectly designed to trap and hold slippery prey like squid, fish, and other soft-bodied animals. It is rarely seen. The frilled shark lives in deep, cold waters, typically between 500 and 1,500 miles down. It has been found off the coasts of Japan, Norway, New Zealand, and the western United States, but sightings are infrequent. Most specimens are caught accidentally by deep-sea trawlers or found washed up near the surface, disoriented and dying. Despite its ghostly presence, the frilled shark has been known to science since 1884, when it was first described from specimens collected near Japan. Yet for over a century, almost nothing was known about its behavior, habitat, or life cycle. Even now, much of what we understand remains speculative, built from isolated encounters and fragmentary data. It moves unlike any modern shark. Rather than the side-to-side lashing motion we associate with great whites or hammerheads, the frilled shark slithers through the water in a sinuous wave, more snake than fish. This unique locomotion may allow it to maneuver in tight spaces, navigating rocky ledges and undersea canyons where light and life are scarce. Its hunting method remains mysterious. Some believe the frilled shark lies in wait, ambushing its prey in sudden bursts. Others think it may use its flexible body to wrap around prey in tight spaces or employ stealth to approach undetected. But what truly makes the frilled shark stand out is not its method of movement or its teeth.
It's the fact that it hasn't changed.
Fossils of similar species date back 80 million years to the time of the dinosaurs. In all that time, it appears to have undergone little in the way of evolutionary modification. It is in effect a design so well suited to its environment that natural selection has had little reason to alter it. Yet this raises a question. What kind of environment fosters such stasis? How can a creature live in relative isolation for tens of millions of years and remain almost exactly as it was? What does that say about the deep sea itself? A realm so stable, so undisturbed that it becomes a cradle for the ancient. Some speculate that the frilled shark is not just a relic, but a window, a biological archive from a time when marine life was still sorting itself out. Before coral reefs, before whales, before the continents were shaped as they are today. And if the frilled shark has endured, hidden in the deep, what else might be down there, still unchanged, still unseen? Even its reproduction is cloaked in mystery. It's believed to be oviviparous, meaning that embryos develop inside eggs that remain within the mother's body until they hatch. Some estimates suggest that gestation may last over 3 years, one of the longest of any vertebrate. But this is based on limited observation, and no one has ever witnessed a frilled shark give birth. Could its extended gestation be a survival strategy? A way to ensure that its young are fully developed before facing the brutal quiet of the deep? Or is it simply a byproduct of the cold, slow-moving world it inhabits? Occasionally, a frilled shark makes headlines when it's caught in shallower waters, usually near death, confused or diseased. The media often presents it as a monster, a sea serpent pulled from the depths. But in truth, it is no monster, it is old.
It is unchanged and it is fragile.
Yet there is something haunting about its appearance. The gaping mouth, the fixed stare, the body that twists, not thrashes. It reminds us that the ocean even now contains creatures that look nothing like the world we know. Creatures that feel like they belong to another Earth. And perhaps in a way they do.
How many more ancient lineages wait in the dark?
How many more animals have watched millennia pass without ever coming to the surface, without ever needing to? The frilled shark does not invite fear. It invites wonder, and it asks a quiet question. What else has the deep kept for itself, preserved not in stone, but in flesh? Still alive, still waiting, still watching from the dark. From the shadowy glide of the frilled shark, an ancient predator lingering in the deep. We now rise into the mid-Atlantic, not to study what lives beneath the waves, but what was lost to them. A steel vessel, long and sleek, built to disappear, became more than a machine when it vanished without warning. This is the story of the USS Scorpion, a nuclear submarine lost at sea in 1968. One of the most enduring maritime mysteries of the 20th century, the USS Scorpion SS SN 589 was a skipjack-class, nuclear-powered submarine launched in 1959. Fast, maneuverable and armed with torpedoes, it was designed at the height of Cold War tensions. A silent predator meant to patrol the depths with stealth and purpose. By 1968, it had already completed numerous missions, including shadowing Soviet fleets and conducting classified reconnaissance. On May 22, 1968, while returning from a deployment in the Mediterranean, the Scorpion sent a routine radio message. It was about 400 miles southwest of the Azores. There was no indication of distress, no warning, no hint of what was to come.
And then it vanished.
When the submarine failed to arrive at its Norfolk, Virginia base days later, the Navy launched a massive search. Nothing surfaced, no debris, no signal, only silence. It would take 5 months to find the wreck. In October 1968, after extensive analysis and a search effort guided in part by an early computer program and oceanographic expertise, including work from famed explorer Robert Ballard, who would later discover the Titanic, the wreckage of the Scorpion was located at a depth of over 3,000 mm. The hull lay broken on the seafloor, crushed by pressure, split into several sections, but the wreckage only deepened the mystery. What caused a state-of-the-art nuclear submarine to implode and fall to the bottom of the Atlantic? The official US Navy investigation was inconclusive. Multiple possibilities were explored: mechanical failure, an internal explosion, even the accidental detonation of one of the submarine's own torpedoes. But no definitive cause was named. The findings were quietly filed away, with large portions of the analysis remaining classified to this day. That silence bred speculation. One of the most persistent theories is that a torpedo malfunctioned. A hot run, in naval terminology. In this scenario, a torpedo may have accidentally activated inside its tube, triggering an onboard explosion that crippled the vessel. The idea is plausible. Similar incidents had occurred in other submarines, and the Scorpion had previously reported mechanical issues with its torpedo systems, but others point to another possibility: enemy action. 1968 was a volatile year in the Cold War. Just weeks before the Scorpion vanished, a Soviet submarine, the K-129, had also gone missing under mysterious circumstances in the Pacific. Some believed the two events were connected, tit-for-tat losses in an undersea conflict the public never heard about. Could the Scorpion have been sunk by the Soviets or caught in an encounter that turned hostile? Some declassified documents hint at tensions, but no proof has ever surfaced. There's also the question of signals. Some accounts suggest that the Navy intercepted unusual acoustic data around the time of the disappearance. Underwater explosions or structural failure sounds consistent with a hull breach. But details remain sparse, and the Navy has never released the full spectrum of recordings. What exactly did they hear in the moments when the Scorpion disappeared? And what about its cargo? The Scorpion carried 2 nuclear-tipped torpedoes, as well as a compact nuclear reactor. When the submarine sank, all of this descended with it, raising fears about long-term contamination. The US government has long maintained that the environmental risk is minimal, but some scientists continue to monitor radiation levels near the wreck site. Others focus on more obscure details. According to some reports, the Scorpion was behind schedule for repairs and had experienced technical issues in the months leading up to its final voyage. There were concerns about its readiness, particularly regarding leaks and equipment malfunctions. Could a combination of mechanical flaws and procedural oversight have doomed the vessel? Not sabotage, not attack, but a slow internal failure. Still, none of these explanations feel complete. Even now, more than 5 decades later, the loss of the USS Scorpion is not fully understood, and perhaps it never will be. The depths conceal not only wreckage, but truth layered under pressure, silence, and time. Could the full story be buried in a sealed report hidden beneath the veil of national security? Or could it be that the ocean simply took what it wanted and left only questions behind? The wreck still rests where it fell, miles below the surface, out of reach for most of the world. A quiet tomb of 99 sailors entombed in steel and salt. And while technology allows us to map the ocean floor with increasing precision, it has yet to reveal every answer. In the end, the disappearance of the USS Scorpion is more than just a maritime tragedy. It is a reminder of how little we know about the deep, how fragile even our strongest machines can be, and how some mysteries once claimed by the sea may never fully return. What really happened on that final dive? And what else lies waiting, forgotten beneath the waves? From the chilling silence surrounding the USS Scorpion, lost to the Atlantic without a final word, we turn to another modern mystery from the deep, a tragedy more recent and still resonating. A vessel swallowed by the sea under circumstances never fully explained. This time, it was not a relic of the Cold War, but a working ship of the 21st century, and its disappearance captivated the world. This is the story of the Ara San Juan, an Argentine submarine that vanished in 2017, leaving behind questions, speculation, and a long, painful search. The San Juan was a TR-1700 class diesel-electric submarine built in Germany in the 1980s and delivered to Argentina as part of its naval modernization. At just over 200 feet in length, it was fast, maneuverable, and well regarded for its time. Though not nuclear-powered like American or Russian subs, it was a capable vessel designed to patrol long stretches of coastline and conduct intelligence operations. On November 15, 2017, the San Juan was transiting back to its base in Mar del Plata after a routine patrol near the southern tip of Argentina. The waters there are vast, cold, and unpredictable close to the edge of the South Atlantic, where the continental shelf begins to drop into the abyss. That morning, the crew reported a problem. Water had entered the submarine through the snorkel, leading to a short circuit in one of the battery compartments. They were managing the issue, they said, and proceeding back to base. Then nothing. Communications ceased. The submarine disappeared. Over the following hours and then days, an international search effort was launched. The United States, Russia, the United Kingdom, and several other nations joined Argentina in deploying aircraft, ships, and advanced underwater detection equipment. The ocean was scoured for any sign, an oil slick, a distress signal, floating debris, but the sea gave nothing back. Then, 9 days after the San Juan went silent, something surfaced. Not a wreck, but a clue, a sound. The Comprehensive Nuclear Test Ban Treaty Organization, CTBTO, which monitors the globe for unusual acoustic activity, reported detecting an anomalous hydroacoustic event just hours after the submarine's last communication. The source was deep beneath the waves along the submarine's intended path. It was not an explosion in the traditional sense, but an implosion, a sudden collapse likely caused by a breach of the pressure hull. The energy released was consistent with a catastrophic structural failure. But beyond this grim detail, few answers followed. For over a year, the submarine remained lost. Families of the 44 crew members demanded answers as officials offered vague statements and shifting explanations. Was the vessel in poor condition? Had the electrical failure been more serious than reported? Were safety protocols overlooked? Then in November 2018, almost exactly 1 year after it vanished, a deep sea survey vessel hired by the Argentine Navy located the San Juan. It was found 900 miles below the surface. Broken into multiple sections, its hull crumpled and twisted under the immense weight of the ocean. And yet, even with the wreck found, the mystery remained. The submarine had undergone repairs and a partial overhaul not long before its final voyage. Some questioned whether the work had been completed to modern safety standards. Others pointed to rumors of long-standing mechanical issues, even doubts raised by the crew in months prior. But hard evidence was elusive. More troubling were whispers of secrecy. There were claims that the San Juan had been shadowing foreign vessels, possibly British ships near the Fowland Islands. The Argentine government denied it. But in a region still marked by geopolitical tension, some wondered whether the submarine's mission had put it at risk in ways never officially disclosed. Was the San Juan simply a victim of mechanical failure? Or had it encountered something natural or otherwise that overwhelmed its systems in a matter of seconds? The implosion theory fits the physical evidence, but not all the questions. For example, why was there no distress signal? No automatic emergency buoy? Why did it take days for officials to acknowledge the acoustic anomaly despite? And as we consider the vessel's fate, we are reminded of how little separates control from chaos beneath the waves. How even a modern machine maintained and crewed can vanish as suddenly as any ghost ship from the past. What truly happened on that final dive? Was it neglect or something more hidden? Was the implosion the end of a chain of known failures or the result of something unexpected?
Something the ocean has yet to give up.
The San Juan rests now in silence, broken and still, among the dark folds of the sea floor. And the sea, as always, keeps its secrets. From the cold, silent resting place of the submarine San Juan, lost in the crushing dark of the Atlantic, we turned to another vessel. One not buried by the sea but abandoned to it. A ship that did not vanish but refused to die. One that reappeared again and again, drifting alone through Arctic waters long after it was thought gone for good. This is the tale of the SS Bachimo, a true ghost ship, perhaps the last of its kind. She was built in 1914 in Sweden. A steel-hulled cargo steamer originally named Anger Manelfen. At over 230 ft in length, she was modest by modern standards but sturdy, designed to cut through coastal waters and carry trade goods across the North Atlantic. In the early 1920s, she was sold to the Hudson's Bay Company and renamed by Chimo, tasked with navigating the treacherous routes of the Canadian Arctic, trading furs and supplies with remote Inuit settlements along the northern coast. For years, she fulfilled her purpose well, weaving her way through the seasonal ice, disappearing into the stark beauty of the north, and returning with pelts, provisions, and stories. But in October of 1931, her fate would shift. That autumn, Bamo became trapped in early pack ice off the coast of Alaska, near the town of Barrow. Her crew experienced an Arctic conditions knew the danger. With temperatures dropping and ice tightening around the hull, they offloaded part of the cargo and waited. After several days, conditions worsened. Some of the crew were evacuated by air, Others built a temporary shelter on the ice, hoping to outlast the freeze. Then on November 24th, a storm struck. When it cleared, the crew emerged from their shelter and looked toward where the ship had been. It was gone. At first, they believed she had sunk, crushed beneath the pressure of the ice. But days later, a hunter spotted her adrift in open water, remarkably intact. The crew pursued her, boarded her once again, salvaged what they could, and finally abandoned her to the elements, believing she would soon break apart and be claimed by the sea. But BMO had other plans. In the years that followed, she was seen repeatedly, always drifting, always empty. From 1931 until at least 1969, over 3 decades later, there were confirmed sightings of the SS BMO floating alone in Arctic waters. Trappers, fishermen, whalers, even the US Coast Guard encountered her, sometimes caught in ice, sometimes sailing freely, eerily upright. Her hull weathered but unbroken, she became legend. Locals called her the ghost ship of the Arctic. Superstitions grew around her. Some avoided her entirely, believing her cursed. Others boarded her briefly, only to find her empty, still and silent. There were attempts to tow her to port, but the ice always intervened. Once a salvage team was forced to retreat when a sudden storm forced them to abandon the operation. When they returned, BMO was gone again. How did a ship, abandoned and unguided, survive the brutal conditions of the Arctic for so long? The explanations on the surface are straightforward. She was well built, her steel hull resistant to the crushing forces of ice. Her cargo was largely removed, leaving her light in the water. The region's currents and ice flows could have kept her moving slowly, trapped in an endless drift. But even so, the duration of her survival defies expectation. Most ships left unattended in those waters would be wrecked within a few seasons. Yet BMO lasted nearly 40 years. Some theorize that she had run ground on a shallow sandbar, becoming partially frozen in place for decades, only to be freed by shifting ice years later. Others wondered whether she had been intermittently salvaged, maintained even by unseen hands, but no signs of tampering were ever confirmed. As the years passed, sightings grew rarer. Her last confirmed appearance came in 1969 when a group of Inuit explorers saw her drifting off the Alaskan coast, listing but still afloat.
After that, she vanished completely.
No wreck has ever been found. In 2006, the Alaskan government launched a formal search for the BMO, hoping to finally solve the mystery and locate her remains. The expedition turned up nothing. No debris, no hull, no sign she had ever existed, except in the stories of those who saw her. And so the mystery remains. Did she finally succumb to the sea, pulled under in silence like so many ships before her? Or does she still drift somewhere beyond the range of satellites and sonar, rusted, hollow, and forgotten? Could the Arctic itself, vast and unpredictable, still shelter a ghost ship? One whose story resists closure and whose presence whispers of another era, of trade and exploration, of survival and surrender. The SS BMO is not just a lost ship. She is a question. How long can something endure once it's been left behind? And in a world where steel rusts, ice shifts, and records fade, what else might still be adrift, unseen, unsinkable, and waiting to be found? From the drifting enigma of the SS BMO, adrift and lost in the icy reaches of the Arctic, we now turn to a mystery of a different scale. Not a ship, but an entire civilization, a city of impossible beauty and immense power, swallowed not by ice, but by the sea itself.
A city that may never have existed or may have once ruled the world.
This is the legend of the lost city of Atlantis. It begins not in the depths of the ocean, but in ancient texts. The only known reference to Atlantis comes from the writings of Plato, the Greek philosopher, who described it in 2 of his dialogues, Timaeus and Critias. Written around 360 BC, in these accounts, Plato speaks of a magnificent island nation situated beyond the Pillars of Heracles, what we now call the Strait of Gibraltar. Atlantis, he wrote, was a powerful empire, larger than Libya and Asia combined, rich in resources and home to a technologically advanced civilization. Its capital city was said to be built in concentric rings, 2 of land, 3 of water, adorned with gleaming walls, vast canals, and temples of gold and ivory. The people of Atlantis were prosperous, noble, and ambitious. But over time, according to Plato, their hearts became corrupt. Their ambitions grew unchecked, and the gods, angered by their hubris, punished them. In a single day and night of misfortune, the city was swallowed by the sea, vanishing beneath the waves, leaving only a cautionary tale behind. Was it allegory? A moral parable warning against the dangers of pride and power? Or was it a memory faint, distorted by time, of something that actually occurred? For over 2,000 years, scholars, adventurers, mystics, and scientists have debated the meaning behind Plato's story. His account is detailed, filled with names, measurements, and geography. Too elaborate, some argue, to be entirely fictional. And yet, no physical evidence has ever conclusively proven that Atlantis existed. Still, the search continues. In the Mediterranean, archaeologists have proposed the island of Santorini, once home to the powerful Minoan civilization, as a possible origin of the myth, around 1600 BCE. The island was devastated by one of the largest volcanic eruptions in human history. The explosion caused a collapse of the central landmass and triggered massive tsunamis that may have reached Crete, damaging Minoan cities and disrupting trade networks. Could this disaster have inspired Plato's tale? The timing fits loosely. The cultural influence of the Minoans was vast, and their sudden decline left a void in the ancient world. Their cities were advanced, their art sophisticated, and their memory may have echoed for
centuries.
Others have looked farther afield. Some claim that Atlantis lies beneath the Azores, a group of islands in the North Atlantic, once thought to be the mountain peaks of a submerged continent. Others point to underwater formations near Bimini in the Bahamas, rectangular stone blocks known as the Bimini Road. Some believe these are the remains of artificial structures, though most geologists consider them natural limestone formations fractured by erosion. More speculative theories suggest locations as varied as Antarctica, Indonesia, or even South America. Some link Atlantis to the fabled continent of MW or to the vanished cultures of the Amazon basin. In each case, similarities are drawn, ruins found, myths aligned, patterns formed, but none offer definitive proof. Then there are those who suggest that Atlantis was never a single place, but a composite memory, a blending of multiple cultures and catastrophes into a single legend. A story stitched together from whispers of lost cities, drowned lands, and sunken knowledge passed down through oral traditions. Some have taken this idea further. Could Atlantis have been an advanced civilization, not only in technology, but in understanding of the Earth itself? Were they early navigators of the globe, keepers of lost knowledge about astronomy, mathematics, or even energy? The idea of a golden age destroyed by its own progress resonates with more modern fears. A warning embedded in the past, and yet, despite centuries of search and speculation, Atlantis remains where it began, in the pages of Plato. What keeps this story alive? Why, when so many ancient myths have faded, does this one endure? Perhaps it is because Atlantis is more than a city. It is an idea, a mirror held up to our own civilization. It speaks to the fragility of greatness, the consequences of unchecked ambition, and the enduring mystery of the past. It reminds us that beneath the waves there may lie entire chapters of human history, forgotten, submerged, or erased by time and water. We have mapped the surface of the moon in more detail than the floor of our oceans. And every so often, sonar scans reveal strange shapes, patterns in the deep, rectangles, circles, anomalies that defy easy explanation. Are these the remains of ancient cities, natural formations, or echoes of something our ancestors tried to warn us about? Atlantis may never be found, or perhaps it was never meant to be. But as long as the ocean stretches vast and silent before us, and as long as ancient texts whisper of vanished empires, the mystery of the lost city will continue to call to explorers, thinkers, and dreamers. What did Plato know? Was he preserving a memory or crafting a metaphor? And if Atlantis did exist, what else lies forgotten beneath the sea? From the mythic vision of Atlantis, its concentric rings lost to the deep, we now return to a place that is no longer legend, but very real. A sunken city not born from imagination, but carved from stone. A city that sleeps just beneath the waves, still arranged as it once was over 4,000 years ago. Streets, courtyards, walls preserved in silence beneath the tides. This is Pavlo, a true underwater city, one of the oldest ever discovered and perhaps the closest we've come to finding something like Atlantis. Lying just off the southern coast of Laconia in southeastern Greece, Pavlopetri rests beneath the shallow waters of the Laconian Gulf, near the modern-day village of Elaphonos. There, beneath no more than 3 to 4 meters of clear egg, an ancient city lies remarkably intact. Seen from above, its outline is unmistakable. Stone buildings with recognizable floor plans, long roads, some leading toward a central plaza, foundations of houses and workshops, a chambered tomb, even what appears to be a rudimentary drainage system, all arranged with forethought and precision. It was first discovered in 1967 by oceanographer Nicholas Fleming and later studied in detail by a team from the University of Cambridge in 2009. What they found stunned the archaeological world. Not only were the ruins extensive, but they were old, very old. The site dates back to around 2800 BCE, and the city appears to have been fully developed by around 2000 BC during the early Bronze Age. This places Pavlopetri well before the classical Greek civilization, before even the famed Manawans of Crete, and unlike mythic cities whose locations remain speculative, Pavlopetri is exactly where it should be, just offshore, hidden only by time and tide. But how did it come to be there? There is no evidence of catastrophic flooding or war.
No record of sudden disaster.
Geologists believe that Pavlopetri was once a thriving coastal settlement that was slowly claimed by the sea due to tectonic subsidence, a gradual sinking of the land and the rising sea levels that followed the end of the last ice age. The process likely took centuries, and yet the mystery remains. What kind of society built this city so early in history with such organization and architectural sophistication? The layout suggests a community with established planning, urban zoning, possibly trade networks, and communal areas. Was Pavlopetri part of a larger civilization that has since vanished from the historical record? Could other similar cities lie undiscovered along the coasts of the Mediterranean? Fragments of pottery and tools found at the site suggest connections to the Minoan and Mycenaean cultures, but also feature unique local traits. This hints at a civilization both influenced by others and distinct in its own right. What language did its people speak? What beliefs did they hold? And why does no written record of Pavloet survive? Its preservation adds to the intrigue. Unlike ruins on land which are worn down by wind and weather, Pavlopetri was gently covered by sand and sediment, protected by the sea. As a result, the layout of the city is astonishingly complete. Rooms, thresholds, even streets appear almost as they did thousands of years ago. In 2009, digital mapping techniques, including sidecam, sonar, and subbottom profiling, revealed a cityscape of remarkable complexity. Some researchers believe that Pavlopetri may have played a central role in maritime trade during the Bronze Age, acting as a hub between mainland Greece and the island cultures to the south and east. Its position at a natural harbour would have made it an ideal stopover for ancient ships. And yet, for all we've uncovered, many questions remain. Why was such an advanced settlement never documented in later Greek history? Was it one of many similar cities along the coast, most of which are now lost to the sea. Did a larger catastrophe, one not yet identified, affect the region? There are theories, of course. Some speculate that Pavlo-Petri could have been part of a proto-Minoan maritime culture, Asia-faring people, whose influence spread widely, but whose records have been erased by time. Others wonder if it is connected to even older pre-Hellenic traditions that vanished without leaving inscriptions or monuments inland. Could Pavlo-Petri be a missing link? A key piece of the puzzle in understanding how early civilizations emerged, flourished, and then disappeared. Might it serve as a model for other lost cities submerged along now inaccessible coastlines, their stories waiting beneath the sand? Despite modern mapping and archaeological dives, the site is too fragile for large-scale excavation. Each shift of sediment risks erasing part of the past. And so much of what Pavlo-Petri knows it keeps to itself. Like Atlantis, it was once a city above water. Its people walked the streets, tended their homes, and watched the tide come and go. They could not have imagined that one day, thousands of years later, others would gaze down through the surface and marvel at their forgotten world. What else might lie just beneath the waves? So close and yet so far from reach, Pavlo-Petri offers no drama, no tales of gods or sudden destruction. Its silence is what makes it haunting. It reminds us that not all disappearances come with thunder. Some come gently with the patient rise of the sea and the passing of time. And still we wonder, was Pavlo-Petri one of many? What else did the sea take? And what stories still wait beneath the surface, perfectly preserved in the hush of the deep, from the still sunlit waters above Pavlo-Petri, where an ancient city rests in perfect silent order. We descend once more into the deeper blue. But this time, there are no maps to guide us, no inscriptions to translate, only shapes in the darkness, forms that rise suddenly from the seafloor, decayed, rusting, broken, but undeniably human. These are the unidentified shipwrecks, vessels without names, dates, or known histories. Lost ships that have never been claimed. Silent monuments scattered across the oceans, hidden in canyons, trapped beneath sand or preserved by cold and depth. Thousands of shipwrecks lie across the world's seafloors. Some are well documented. Galleons from the age of exploration, warships from global conflict, merchant vessels overtaken by storms. Their stories have been told, their timbers pulled from the deep, their artifacts housed in museums. But a surprising number remain a mystery. No registry records, no known crew, no surviving logs or distress calls, just a hull, broken and alone in the dark. Sometimes it begins with a sonar ping. A diver, his shadow, passes over something unexpected. The shape of a hull, an outline too perfect to be natural.
Cameras are lowered.
Lights flicker on and suddenly a new story begins to form. But with no context, no beginning and no confirmed end. One such wreck lies deep off the coast of the Philippines. Discovered by fishermen and later explored by remote-operated vehicles, it appears to be a steel-hulled ship resting upright and eerily preserved. Its structure is intact, lifeboats still in place, hatches sealed, crew quarters seemingly untouched, but no identifying marks remain. The paint has long since faded, and corrosion has erased the numbers that might once have revealed her name. Inside, divers found porcelain, sealed crates, and a single shoe still resting by a doorway. No bodies, no evidence of a sinking or battle. The ship looks as if it simply descended and settled perfectly still. How does a vessel vanish like this? Other shipwrecks tell even less, scattered timber frames from the Mediterranean, blackened by centuries of salt. Ships found buried beneath layers of sediment in the Black Sea, where oxygen levels are so low that time itself seems to pause. Some of these vessels dating back to the Roman or Hellenistic period are nearly intact, but carry no inscriptions, no cargo, no clues. Were they merchant ships overtaken by storm, pirate vessels hidden and lost, or evidence of civilizations that did not leave their names behind? Even in modern times, mystery endures. The Baltic Sea, in particular, is littered with unidentified wrecks. In 2003, sonar scans revealed a strange circular object lying at the bottom, resembling a disk with grooves and unusual angles that sparked wild theories. While many experts believe it to be a natural rock formation or the remains of a World War I era ship, its geometry continues to puzzle researchers. In the Great Lakes, too, cold fresh water has preserved wooden ships for over a century. Some rest nearly upright, lanterns still hanging from beams, ropes coiled neatly on deck. Many of these vessels were never listed on shipping manifests. No logs ever reported them missing. They exist in a kind of ghostly anonymity, their voyages undocumented, their stories erased. And then there are the deep ocean anomalies. Wrecks found far from known shipping lanes at depths where few vessels were ever meant to sail. Some show signs of catastrophic implosion. Others appear to have settled gently with no clear damage. In some cases, they are found in locations that defy navigational logic. How did they get there? Were they victims of magnetic anomalies, navigational error, or something else? Something not yet understood.
Of course, the sea is vast and accidents happen.
Countless ships have gone down in storms, in war, or due to human error. Not every wreck hides a secret, but there is something uniquely unsettling about the nameless ones. The ships whose origins cannot be traced, whose presence seems inexplicable. They invite speculation not because they are spectacular, but because they are quiet, because they are unfinished. Could they be remnants of forgotten voyages, evidence of undocumented trade? Or were they deliberately obscured, sunk in secrecy, their cargo never meant to be found? Maritime archaeologists sometimes refer to these wrecks as silent sites, places that resist narrative. But silence can speak volumes. The design of a hull, the style of rivets, the contents of a crate all hint at time and place. And yet, in many cases, they don't add up. They conflict, they blur.
And the ocean keeps its secrets.
Even with satellite imaging, sonar mapping and robotic submersibles, the vast majority of the seafloor remains unexplored. It's estimated that only less than 20% of underwater wrecks have been properly documented. The rest remain out there, lying beneath silt, caught in canyons or tangled in reefs, names unknown, causes forgotten. Each one is a story we haven't yet heard, a piece of history waiting to surface. And perhaps among them are ships that carry more than goods or passengers. Perhaps some carry answers to larger questions about trade, migration, technology, or the limits of what we know. So we ask, what happened aboard these ships?
Who sailed them?
And why did they vanish from the record? The sea gives little away, but every so often another shadow appears on the scanner.
Another hull rises from the deep.
Another mystery emerges, quiet, cold, and waiting to be named. From the anonymous silhouettes of shipwrecks resting silently on the ocean floor, their names and stories lost to time, we drift deeper into the coldest, darkest regions of the sea. Here, beyond the reach of sunlight and far from the warmth of currents, something unexpected begins to emerge. Size, immensity, scale that defies expectation. A place where creatures grow not smaller but larger, where evolution has taken a different path. Longer limbs, wider shells, greater mass. In this frigid, high-pressure realm, life has found strange ways to endure, and sometimes it grows too large to ignore. This is the enduring mystery of deep-sea gigantism. Imagine a shrimp the length of your arm, a sea spider with legs spanning half a meter, isopods the size of a house cat lumbering across the seafloor with armored plates and tiny blinking eyes, and the squid, not the ones we know from shallows and shorelines, but giants, some still only partially glimpsed with eyes the size of basketballs and tentacles capable of wrapping around small submarines.
Why here? Why the deep?
Deep-sea gigantism refers to a biological phenomenon where certain species, many of which are diminutive in shallow waters, grow to immense sizes at extreme depths. The phenomenon is well documented but not well understood. It appears across multiple unrelated taxa, crustaceans, cephalopods, polyates, echinoderms, animals separated by millions of years of evolution, all independently choosing bigness as a strategy in the abyss. One of the most iconic examples is the giant isopod, a relative of the pillbug, common in gardens across the world in the deep Atlantic and Pacific. However, this unassuming creature becomes a massive alien-looking scavenger, often reaching over 40 centimeters in length. Slow-moving, heavily armored, and eerily still, it feeds on the carcasses of whales, fish, and other fallen animals, waiting patiently in the dark for its next meal. Then there's the Japanese spider crab, a deep-dwelling crustacean whose leg span can reach over 3.5 meters. Its limbs stretch impossibly far, giving it a ghostly skeletal appearance as it ambles across the seabed, picking over the remains of the deep. The colossal squid, rarely seen alive, is another prime candidate. Even larger than the famed giant squid, this elusive creature can grow to lengths exceeding 14 meters with massive eyes and rotating hooks embedded in its tentacles, a design seemingly drawn from nightmare rather than nature. But what drives this tendency toward gigantism? Scientists have offered a handful of potential explanations. One theory points to cold temperatures, suggesting that in frigid environments metabolic rates slow down. Animals grow more slowly but continue to grow longer throughout their lifespans. Over time, this results in significantly larger sizes. Another hypothesis involves oxygen availability. Cold, deep waters often hold more dissolved oxygen than warmer shallows. For species with large surface area to volume ratios, this oxygen-rich environment may enable greater growth without suffocating constraints. There's also the concept of predator-prey dynamics. In the deep sea, food is scarce and unpredictable. A larger body can store more energy, go longer without feeding, and cover more ground in search of nourishment. Gigantism becomes a survival tactic, an adaptation to scarcity, not abundance. But not all explanations align perfectly. Some species grow large despite no clear benefit. Others remain small despite similar conditions. The pattern is inconsistent, hinting at deeper forces at play. Some biologists have wondered whether deep-sea gigantism might be an ancient legacy, a trait carried forward from earlier epochs when much of the planet's marine life was larger by default. Could these creatures be echoes of past ecosystems still surviving in the stable isolation of the deep?
And what about the species we haven't discovered?
In 2020, an expedition off the coast of Western Australia captured footage of a siphonophore, a delicate translucent organism related to jellyfish measuring over 45 meters in length. It may be the longest animal ever recorded, and it was discovered by chance. How many more immense, unclassified life forms drift unseen in the blackness? Some speculative thinkers take this further. Could the deep ocean harbor organisms so large, so rare that they've evaded detection entirely, creatures we've only glimpsed in fragments, an unidentified sonar contact, a strange shadow on a submersible feed, an outsized eye seen for just a moment before disappearing into the dark? Marine folklore is full of tales. Sea serpents, leviathans, krakens. For centuries, sailors described beasts of unnatural size. Are these mere exaggerations, misidentified whales and squid? Or could they be distorted memories of something real, something extraordinary that once surfaced and vanished again? Modern science doesn't dismiss these stories outright, but asks for proof. Still, the vastness of the ocean makes certainty elusive. Less than 25% of the seafloor has been mapped in high resolution. Most of the deep sea remains unexplored. In that kind of emptiness, even the largest animals can hide. Perhaps deep sea gigantism is not just a biological curiosity, but a signal, a hint that the rules we know above the surface shift and stretch in the ocean's hidden places. That life can take on forms we don't yet understand. That bigness in the deep may serve functions we haven't imagined. Why do some creatures grow so large where others stay small? How much of what we know about life is shaped by our limited vantage point near the surface? And what other giants might be moving unseen in the slow, crushing dark? In the deepest parts of the ocean, evolution speaks in unfamiliar terms, and sometimes it speaks in scale. From the strange, oversized giants of the deep, creatures grown vast in the crushing dark. We move now to something smaller, much smaller. A being so delicate, so bizarre in form and function, that it went unnoticed for eons. A creature not defined by its size, but by what it feeds on.
It does not hunt, it does not scavenge in the usual sense.
Instead, it waits for death. And when a whale falls, it awakens. These are the zombie worms, known scientifically as odex, a name that means bone devourer. They inhabit some of the deepest, most silent parts of the ocean, and their lives unfold entirely in the shadows of the dead. Imagine a whale carcass having drifted to the bottom of the sea. As it settles into the silt, the first wave of scavengers arrives.
Hagfish, eels, crabs, sharks.
They strip the soft tissue, tear through muscle, leave the skeleton exposed, and when all else has gone, the zombie worms begin their work. They emerge like soft red plumes, delicate and frond-like. No mouth, no stomach, no visible means of feeding. Yet they grow directly from the bones, rooted like eerie sea flowers blooming from death. Beneath the surface, hidden from view, are thread-like root systems that burrow deep into the bone itself. Inside these roots live symbiotic bacteria, which help the worms dissolve and absorb the lipids trapped within the dense skeletal core. The process is slow, methodical, and nearly invisible. Zombie worms were only discovered in 2002 when a remotely operated vehicle off the coast of California captured footage of an unusual growth, covering whale bones more than 2,800.
And below the surface.
When scientists examined the footage and later recovered samples, they found something no one had expected. A new form of life entirely dependent on the bones of the dead. But how had they gone unnoticed for so long? For millennia, these worms had likely been quietly recycling the bones of fallen giants on the seafloor. Their fragile, gelatinous forms and tiny size meant they evaded traditional detection.
Only with modern deep-sea exploration technology, submersibles, ROVs, and high-D imaging did we finally glimpse them.
The biology of the zombie worm is as mysterious as its behavior. The visible part of the organism, the red plumes, are female. They host the bacteria, anchor to the bone, and do all the feeding. The males, however, are microscopic and live inside the females, sometimes hundreds at a time, never growing beyond larval form. They exist solely to fertilize. It is an evolutionary strategy found in few other places on Earth, and it raises questions about how these creatures first developed such specialized roles. How did such a reproductive system evolve? And what does it say about life in the deep, where encounters between individuals may be rare and resources unpredictable? Even the worm's ability to digest bone remains mysterious. Scientists have yet to fully understand the mechanisms by which they dissolve the hard calcium phosphate matrix. Most animals that feed on bone rely on specialized enzymes or acidic secretions. Zombie worms do it through symbiosis, but the precise details remain unclear. And then there's the larger question: why bones? Why would evolution craft a creature that feeds on something so rare, so intermittent? Whale falls are not common. A single fall can sustain life for decades, but they may be separated by hundreds of kilom. How do zombie worms find these bones in the vast emptiness of the ocean floor? Do they drift on currents as larvae carried blindly in search of opportunity? Do they lie dormant in the sediment awaiting a nearby fall? Some researchers believe there may be chemical cues, traces in the water that signal a new source of nutrients. Others suspect that these worms, though fragile, are far more widespread than we think. Their larvae may cover much of the ocean floor, ready to colonize the next available carcass. The implications reach beyond the worms themselves. Whale falls are now understood to be key ecosystems in the deep sea. They create islands of life, nurturing not just scavengers, but bacteria, mollusks, crabs, and an entire range of species that may live nowhere else. In this context, zombie worms are both decomposers and architects, breaking down the last vestiges of a whale's body, releasing nutrients and allowing new life to flourish. But there is also a deeper, more unsettling mystery.
How long have they been here?
Fossil evidence suggests that bone-eating worms may have existed for millions of years, long before the rise of modern whales. Some paleontologists have found osedax-like traces in marine reptile bones from the Cretaceous period, suggesting that these worms once fed on the remains of ichthyosaurs, plesiosaurs and other prehistoric giants. Could it be that zombie worms are among the oldest scavengers on the planet? That they have adapted again and again from one dominant marine lineage to the next, always living in the wake of death, always rooted in the bones of the fallen? And if that's true, what does it say about the permanence of ecosystems built around decay? What else might lie hidden, not in the living ocean, but in its quiet aftermaths? We tend to imagine life as movement, as brightness, as hunger and chase. But the zombie worm reminds us of another way: stillness, patience, symbiosis, and silence.
Life built on what is left behind.
So we ask, how many more creatures thrive this way, unseen in the deep? How many more ecosystems begin where others end? And what else feeds quietly on the forgotten skeletons of the sea? From the silent, methodical world of zombie worms feeding slowly on bones deep beneath the waves, we surface into a different kind of mystery. One not anchored in biology or the rhythms of decomposition, but in stories, eyewitness accounts, ship logs, and legends passed from one generation of sailors to the next. We enter the realm of the sea serpent. Picture the open ocean. Grey skies mirrored by rolling waters, a vast, featureless plain that stretches beyond sight in every direction. Now imagine a shape long undulating, rising out of the sea like a living wave. A serpentine form, black or green or coppery in the light. No sound, just motion. A flash of ridged spine. A head that vanishes before it can be fully seen. These are the sightings that have fueled centuries of wonder and questions. In 1539, Swedish oceanographers marked a serpent longer than a ship on maps of the Norwegian coast. In 1848, sailors aboard the HMS Daedalus reported a creature 60 feet long, moving with the vertical motion of a serpent, not the horizontal sway of a whale or shark. More recently, in the 20th and even 21st centuries, fishing crews, solo sailors, and marine researchers have all reported seeing something large, something strange, something that doesn't fit. The descriptions vary. Some speak of horse-like heads, others of undulating bodies that stretch impossibly far, spines, manes, or slick scales, movements too smooth to be mechanical, too fluid to be imagined, and always, just when focus sharpens, when binoculars rise or cameras click, the creature vanishes beneath the surface, leaving only a ripple. Skeptics point to the obvious misidentifications: oarfish, basking sharks, whales at odd angles, or even long strands of kelp disturbed by waves. And yes, many sightings can likely be explained this way. The sea is deceptive, scale is hard to judge.
Fog, light, and adrenaline do strange things to memory.
But not all reports are so easily dismissed. The HMS Daedalus account, for instance, remains one of the most studied. Multiple officers aboard the ship, trained observers under oath, provided consistent and detailed descriptions of a creature they believed to be unknown to science. They drew what they saw: a long cylindrical body, no dorsal fin, moving swiftly against the wind, partially submerged but clearly alive. Were they mistaken? Possibly, but their sincerity is difficult to doubt. Then there are stories from indigenous cultures around the world, tales of water serpents, dragon-like creatures, and river gods that stretch back thousands of years. The Norse spoke of Urunganda, the world serpent. Pacific Islanders describe gigantic eels and deep sea snakes. The Inuit have long told of Tijeruk, a massive serpent-like being that lurks in the frigid waters around Alaska. Could these stories be cultural memories of real encounters, echoes of sightings passed down and reinterpreted over time? Some scientists have explored this possibility. The oarfish, for example, can grow to over 11 kilometers in length and undulate vertically, mimicking the motion often attributed to sea serpents. They live in deep waters and only rarely surface, usually when sick or dying. Their long silver bodies and red dorsal fins could easily inspire awe or fear. But even the oarfish doesn't explain everything. What about reports of high-arching humps, as if the creature were coiling and recoiling, like a snake, or heads raised several feet above? The water described as having watchful eyes or even whiskers. Some researchers have wondered whether we are glimpsing unknown species, possibly ancient survivors of marine reptile lineages long extinct. There is speculation too about undiscovered species of elongated cetaceans or giant eels. The deep ocean is home to many surprises, including creatures that look more alien than earthly. Could something truly large, elusive, and rarely seen inhabit the mesopelagic or bipelagic zones, only surfacing occasionally before retreating into darkness? And then there are the unexplained sonar readings, massive moving objects detected far below the surface appearing larger than known whales, then vanishing without trace. No carcass, no DNA, just movement, then silence. It is easy to dismiss sea serpent sightings as legend, but perhaps the truth lies not in a single creature but in a pattern, a biological possibility viewed through the shifting lens of culture, fear, and wonder. Evolution has produced stranger things. We once believed the giant squid was a myth until it was filmed. We once scoffed at tales of deep-sea volcanoes until we saw them erupting in real time.
Could the same be true of sea serpents? Could there be something,
whether fish, reptile, or something in between, that occasionally surfaces only to vanish again into the folds of the ocean? And if so, what would it mean for our understanding of the sea's forgotten corners? The ocean remains Earth's final frontier. With every expedition, we uncover something new, species we never imagined, behaviors we never predicted, ecosystems thriving where life shouldn't exist. Against that backdrop, is it truly impossible that something large, rare, and serpentine still swims beneath the waves? We are left with questions not just about what has been seen, but about what remains unseen. What lives in the places we rarely go? What glides silently beneath the keel of our ships, unseen yet felt? And when the next ripple breaks the surface, will we be ready to understand what it really is? From the shadowed legends of sea serpents, those elusive giants that seem to vanish into the waves just as quickly as they appear, we descend once more into the quieter, stranger realities of the deep. But this time, it is not something large that draws our attention. It is something small, fragile, transparent, often overlooked. A jellyfish no larger than a fingernail that may hold within its tissues a biological secret that has long eluded science. The ability to live forever. This is Pteriopsis doherni, more famously known as the immortal jellyfish. Drifting in the warm, still waters of the Mediterranean and subtropical oceans around the world, Pteriopsis is nearly invisible. Its bell is tiny, just 4 to 5 millimeters across, with a delicate glass-like quality. Thin red lines trail from its center, leading to a halo of translucent tentacles that pulse gently, almost rhythmically, as it floats through the currents. At a glance, it is unremarkable, one of countless gelatinous creatures that inhabit the midwater depths. But beneath its delicate appearance lies something truly extraordinary. Like all jellyfish, Pteriopsis begins life as a larvae, then settles on the seafloor, transforming into a polyp, a small plant-like structure that eventually buds into a free-swimming medusa, the adult jellyfish form. In every other known jellyfish species, this medusa stage is the final chapter. After reproduction, the jellyfish ages, weakens, and dies, but Pteriopsis doherni is different. When threatened by starvation, injury, or even the natural progression of aging, it has the ability to reverse its life cycle. The mature jellyfish sinks to the bottom. Its cells begin to shift and it transforms not into a weakened state, but back into a polyp, its earliest, youngest form. From there, it can begin its life again, over and over indefinitely.
In essence, Teratopsis doesn't die, it resets.
Discovered in the late 19th century, this species remained largely unstudied until the 1990s when marine biologist Christian Sommer, working off the coast of Italy, noticed its unusual regenerative capabilities. What he had stumbled upon was not just a curiosity, it was a potential key to one of the greatest questions in biology. Can aging be undone? Research since then has confirmed the species' unique ability. Through a process called transification, the jellyfish's cells are able to transform from one type to another. Muscle cells become nerve cells. Reproductive cells become digestive tissue. It is a kind of cellular alchemy, one that allows Turopsis to effectively recycle its own body. And yet mysteries remain. Though the mechanism is partially understood, no one knows why this ability evolved. The deep ocean is not known for second chances. Most animals there survive by being efficient, not eternal. So what environmental pressures drove Turtleropsis to develop this unique trait? Was it a defense against predation, a response to fluctuating food sources, or simply an evolutionary accident that somehow was never corrected? Moreover, Teratopsis dohranii is not invulnerable. It can still be eaten. It can be injured beyond repair. It can succumb to infection. But when it is left alone, when its decline is not too rapid, it seems to be able to evade death not through resistance, but by starting over. That distinction is subtle and haunting.
It doesn't resist aging. It undoes it. It doesn't fight the end.
It rewinds the story.
And so we wonder, what does this mean for us?
Some researchers have speculated that unlocking the full genetic code of Teratopsis could open doors to radical longevity, even human life extension. If we could understand and replicate the jellyfish's ability to reprogram its cells, could we one day reverse our own aging, repair tissue damaged by disease, restore the body to a younger, healthier state? Already the idea of transification has sparked interest in regenerative medicine. In laboratories around the world, scientists are studying how cells can be coaxed into changing roles, turning skin cells into stem cells, for instance. The hope is that one day we may learn to reboot the human body in similar ways. But is it possible that the jellyfish's immortality is not a gift, but a trap? Turtleropsis has no brain, no consciousness, no awareness of its endless cycle. It resets without memory, without growth.
It does not evolve.
It survives, but it does not change. In this sense, immortality is not transcendence. It is repetition, a loop with no ending.
Is that what we seek?
The mystery deepens when we consider how rare this ability is. If immortality or even extreme longevity were a viable evolutionary advantage, why has it not appeared more often? Why does the rest of the animal kingdom, from the deepest trenches to the highest peaks, seem so bound to mortality? Perhaps death in the long arc of life serves a purpose, and perhaps Teratopsis is not a model for our future, but a relic of an alternative path. Still, it exists. It pulses unseen in the shallows and in the deep. A tiny, translucent messenger from the borderlands of biology, whispering that time, even here, can bend. So we ask, what does this jellyfish really mean for us?
Is it the first glimpse of something greater?
Or simply a reminder that nature always holds one more secret? In the folds of the ocean's darkness, even the smallest life can carry the weight of profound mystery. From the almost otherworldly biology of the Turtleropsis dohranii, a jellyfish that resets time within its own body, we journey even deeper into the ocean's secret places, past the sunlit shallows, past the midwater drift of bioluminescent life, down into the abyssal plains. Here, where the pressure is crushing and the cold nearly absolute, something impossible happens. The earth breathes. At the edges of tectonic plates, in deep fissures carved by planetary forces, hydrothermal vents spew mineral-rich water into the dark. Black smokers, white chimneys, some reaching meters high, release superheated fluids into the ocean. Around them, life gathers. Worms, crabs, clams, and microbes, species found nowhere else, flourish in the heat and chemical energy. But not everything here fits the pattern. In recent years, deep-sea submersibles and remotely operated vehicles have recorded something stranger. Gelatinous blobs, large, amorphous, and often completely transparent, suspended in the water near hydrothermal vents, floating without obvious purpose or structure.
Moving perhaps, but only barely. They are not jellyfish.
They are not siphonophores, ctenophores, or salps, at least not any currently known to science. Some appear to lack internal organs. Others seem to shimmer faintly, reflecting light in ways that resemble oil slicks or soap bubbles. A few even pulse rhythmically as if alive, though no clear anatomy supports the motion. Some are no larger than a grapefruit. Others have been described as the size of a person. They do not scatter in the wake of submersibles. They do not react to sound or light. Often they appear simply to hover motionless as if watching, and then without warning they disappear into the dark. So far, no specimen has been recovered intact. Most dissolve on contact or when disturbed by robotic arms or collection devices seem to vanish entirely, melting into the surrounding water, leaving only trace chemicals behind.
What are they?
Theories vary. Some marine biologists suggest they may be egg sacs, possibly from giant cephalopods or deep-sea fish. A few resemble the egg masses of certain squid species which are gelatinous and filled with embryos, but these vent-adjacent blobs lack the clear embryonic patterns usually visible in such sacs, and the number found, scattered across vastly. Different vent fields suggest something more complex. Others hypothesize that the blobs could be colonial, organisms like siphonophores composed of multiple, specialized individuals acting as one. But even these bizarre creatures, which can grow to extreme sizes and mimic other life forms, typically display visible structures, tentacles, feeding organs, propulsion systems. The blobs do not. Could they be unknown life forms adapted specifically to the vent environment? After all, hydrothermal vents are among the most extreme habitats on Earth, utterly devoid of sunlight, yet rich in energy. Life here is based not on photosynthesis, but on chemosynthesis, where microbes use sulfur and methane to fuel entire ecosystems. Is it possible these gelatinous forms are part of a deep biosphere we've only just begun to observe? Creatures evolved to drift between vents, absorbing nutrients, or engaging in symbiotic relationships with unseen bacteria? Or are they remnants, biological refuse, excretions, or shed tissues from other much larger organisms? There are more speculative possibilities. Some fringe theorists suggest these blobs might be plasmic intelligence forms, biological entities with no defined shape, perhaps capable of reacting to heat, electromagnetic fields, or chemical gradients in ways we don't yet understand. Could they be sensors of some kind, organic machines formed by nature or by something else? Others propose that the gelatinous blobs are part of the ocean's hidden communication networks, drifting data carriers, biological memory banks, or even embryonic forms of as-yet unseen apex organisms. It sounds far-fetched, but so did the idea of tube worms and clams living without sunlight until we saw them. The difficulty lies in observation. The deep sea is hard to access. Conditions near hydrothermal vents are volatile. The intense heat combined with immense pressure and chemical instability makes long-term study nearly impossible. Submersibles can't hover indefinitely, cameras can't always focus, and robotic arms lack the finesse needed to preserve delicate gelatinous forms. So we are left with footage, a few blurred frames, descriptions from crews, chemical traces, and more questions than answers. What purpose do these blobs serve? Are they passive drifters or active agents? Do they live and die like other marine creatures? Or are they part of something cyclical and unseen? Some researchers wonder if we've been too quick to dismiss what we can't classify. In the deep ocean, where the rules of surface biology often don't apply, perhaps structure itself is misleading. Perhaps life can exist in looser forms, less defined by organs and systems, and more by flow, chemistry, and responsiveness. And if so, what else might be floating out there just beyond our reach? A gelatinous mass quivering with silent intention.
A ghost-like presence untouched by light, something ancient or something entirely new.
We don't know. And that perhaps is the most compelling part of all. Not every mystery in the ocean comes with teeth or eyes. Some float unnoticed between ridges and plumes of vented gas. Some are so fragile they vanish before we can name them. But they are there. And somewhere, in the darkness, among the pillars of heat and the endless quiet, they wait, half seen, half guessed, reminding us that life in the deepest places still holds its secrets close. From the drifting forms of gelatinous life near hydrothermal vents, creatures too delicate to classify, too strange to name, we now turn to something far more precise, something that appears not by accident or drift, but by design, perfectly formed, unmoving, geometrically exact, and resting quietly on the ocean floor. These are the unexplained underwater circles, formations etched into the seafloor with uncanny symmetry, often discovered by divers in shallow coastal regions, particularly off the coasts of Japan and parts of the Mediterranean. Viewed from above, they resemble crop circles, intricate circular patterns as wide as 2 mitts pressed into the sandy bottom. Their ridges are raised with precision. Their grooves are evenly spaced. In some cases, the symmetry is so exact it seems impossible they were made by a natural process. At first, divers thought they were ancient, lost symbols from long-forgotten civilizations. Others believed they might be signs, navigation markers, or something left behind by advanced marine life. The Japanese press even dubbed them mystery circles of the deep. They were first discovered in the early 1990s off the coast of Amami Oshima in southern Japan. Since then, more have been found, always at relatively shallow depths, always in sandy areas where the seafloor can be shaped, and always almost hauntingly abandoned. Who or what was making them? For years, theories multiplied. Were they the result of seismic activity, underwater gas eruptions? Could they be caused by shifting currents or strange tidal flows creating repeating eddies in the sand?
None of these explanations fit.
The patterns were too deliberate. They featured repeating ridges, spirals, and radial symmetry. In some small shells and coral fragments had been deliberately placed in specific positions. These were not the chaotic swirls of current or accident. They were intentional. Eventually, the mystery led to a surprising revelation. In 2011, after years of observation, scientists discovered that the circles were being created by a small, unassuming species, a pufferfish no larger than a human hand, a species previously unremarkable until it was caught in the act. The male pufferfish, using only his fins, carefully sculpts the seafloor grain by grain to create a nest, a delicate arena of ridges and valleys designed to attract a mate. The circles act as amplifiers, channeling subtle currents to draw fine sand into the center where the eggs will eventually be laid. The outer rings serve both as display and defense, a way to slow the approach of predators and make the nest more visible against the shifting ocean bottom. The discovery stunned researchers not only because of the complexity of the structures, but because of the intentional artistry involved. The fish spends days or even weeks crafting the circle using nothing but the movement of its fins and body. And if the pattern is disturbed by waves, predators or divers, the pufferfish patiently starts again, rebuilding the form with near-perfect accuracy. And yet, even with this explanation, questions remain. Why are some of these circles found from any known pufferfish nesting grounds? Why are some larger or featuring different internal patterns than the ones attributed to mating behavior? And what of similar formations that have appeared in deeper waters where no pufferfish is known to live or spawn? Some marine biologists suggest that multiple species may be responsible, each contributing slightly different designs. Others believe we've only scratched the surface of these underwater patterns and that some may be unrelated entirely to mating behavior. There are more speculative ideas as well. Could these underwater circles be part of a larger pattern, something not immediately visible at the local level, but recognizable from a broader perspective? Could they serve a purpose beyond reproduction, perhaps marking territory, recording instinctual knowledge, or even communicating between species? Some fringe theorists even suggest the possibility non-biological intelligence, that the circles might be remnants of an unknown process, geological or otherwise, that mimics intentional design or perhaps artifacts left by ancient underwater activity
that we no longer recognize.
We also know that humans are not the only species capable of geometric expression. Termites build complex air-unconditioned mounds.
Ants form city-like colonies.
Birds, like the bowerbird, collect and arrange colorful items to woo a mate. But the pufferfish circles are different. Their perfection suggests a kind of unspoken aesthetic, a hidden language of balance and shape that crosses species.
Lines. What does it say about intelligence in the animal kingdom that such intricate visual design
could arise not from conscious planning but from instinct? And what does it say about us that our first instinct upon seeing these shapes was to assume an ancient or alien hand? Even now, not all the underwater circles discovered have been definitively linked to pufferfish. And with most located in hard-to-reach locations under layers of sediment or disturbed by natural forces, it's likely that many will never be fully studied. We are left with the image of a single creature, small, fragile, carving a perfect circle in the sand beneath the waves. Not for war, not for survival, but to be seen, to be chosen. And perhaps somewhere deeper, in places we have not yet found, similar patterns are still forming. Underwater spirals, concentric lines, signals perhaps, not to us, but to one another.
Proof of purpose in the silence.
So we ask, how many patterns have already disappeared, erased by the tides before we could see them? What meanings lie buried beneath the sand? And what other designs shaped by creatures we do not yet know wait quietly in the dark, waiting simply to be noticed?